Never try and do this when it's hot because we got live bussing there.
This is the part that scares me.
Drywall screws to hang up this panel without a permit. That's not gonna work. Well, good afternoon, everybody. My name is Steven Landers, and I'm excited to be doing these video courses. I've noticed that a lot of you have responded to questions that I've put at the beginning of the course, asking whether you wanted to do a multiple choice question test or you wanted to do a video course. And a lot of you were saying that you wanted to do a video course. So that's what I'm doing. A little bit about myself before we get started. I've worked on big projects, hospitals, casinos, large 17-story office buildings, big projects like that. So I've had quite a bit of experience getting to see a lot of different electrical installations. And through the years that I have been able to also move into teaching, which is something that has really excited me. I started teaching at the electrical apprenticeship 4 years ago, and that kind of spurred me on so that I can try and bring some good information to electricians. So I know that this is not your favorite thing to do. It's not my favorite either, but we all have to do it. So I'm going to try my best to make it a time that you actually get to learn something, not a time that we just sit here and, do nothing, but you get to learn something. So that's my goal. We're going to go over the electrician administration rules. We're going to do some electrical safety, the National Electric Code. So that is what is required by the TDLR that I go over with you guys. I'm going to try to open up my computer. I'm sharing my screen right now so you guys can see and actually get into some drawings. Get into some real life situations that I've run into so that this isn't just some boring class. I find that if I can bring you into things that I've learned, and it might be a little difficult on your iPad or maybe you're on your phone. You can do it on your phone, absolutely. I'm going to zoom in as much as I can and kind of go over some lighting control stuff, some different things, and then we'll bring in the National Electric Code at the end. This first part's not going to be the funnest. We got to go over this section, but even though it's not fun, it's good to know, because if you want to move from being, let's say, an apprentice to a journeyman, there's stuff in here for you. A journeyman to a master, there's stuff in here for you. Maybe you are a master and you want to start your own electrical contracting company. Well, you have to know these rules. You have to know these laws. So we're going to go through this. And like I said, then we'll do some safety. And then we'll do National Electric Code where it gets a little funner. I'll open up, like I said, my computer screen to some drawings, and we'll go over some different things. So one thing I have to note, in my computer program, I can see how long you took to take this course. The TDLR does require you to spend the full amount of training time. So please make sure that you leave the videos running, that you try to watch them. I know some of you might not, but just use this time to actually learn something. Before we get into the electrician administrative rules, I wanted to share with you a story of something that happened to me on a job site that is extremely important to understand about simple residential electrical panels and 120, 240 volts. So take a look at this video, check it out. This goes along with NFPA 70E safety practices. So you don't think that 120, 240 can hurt you. A lot of people see me in my hot suit and they think that it's way too much overkill. And there's been a couple of you who have read the comments and seen that I discussed how I blew my hand up a couple years back because I wasn't wearing the proper PPE. Well, I wanted to take a couple minutes and go over what happened 2 years ago, what sent me in an ambulance, in a helicopter, all the way to the burn clinic, and an entire month's worth of work off. So let's get right into it. So I got a call from a customer who said that his panel was melting. Something was going on, he could smell burning. We showed up to the house and sure enough, that's what was happening. It looked something like this. This isn't the exact panel, but it did look like this. After I saw the panel like this, I should have immediately called the utility company. That was part of my inexperience working on residential panels. Most of my experience is in commercial, and I was new to changing out residential panels. I should have called the utility. They have an emergency line. They could have come and shut the panel down right away so I could have done my work. But I did not call them, and that was my fault. Basically what happened is I had been working 14 to 16-hour days, really long, really tired. I was exhausted. I was also at the same time trying to teach my apprentice, Paul. So I'm walking through it with him. We start going through
all the breakers, turning off the breakers, pulling the wires off the breakers, labeling every wire so that we knew what breaker to put it back onto. We took all of them off, and then I went straight to taking all the breakers out of the panel. So now we had live exposed bussing. The panel was a really tall panel. All the bussing was exposed, and the one thing, can you guess what I forgot to do? I forgot to turn the main breaker off. The main breaker was way at the top of the panel. The one you see in the picture, the breaker's at the bottom, but it was opposite on the panel that we were working on. I don't have a picture of it, sorry about that. So basically what happened is I took all the breakers out, all the bussing was live. I didn't have any PPE on, I didn't have anything. I completely messed up. So I started taking the grounds and neutrals off, took them all out of there. The breakers were out, and then I loosened the lug for the ground wire that goes down to the ground rods, and I pulled the number 4 bear off, and I went to shove it out the bottom of the panel. As I was shoving it out the bottom of the panel, it slipped out of my fingers and it crossed 240 volts and it blew up right on my hand. It blew up and it looked just like this right after. As you can see, my hand is all charred. The skin was super tight. Everything had gotten burnt to a crisp and I couldn't even bend my hand. None of my fingers could bend. It was just imagine a burnt piece of toast is what my hand was. So we ran over really quick. I rushed, I was shaking. I ran over to the truck with Paul and we hopped into my truck and I was gonna drive myself to the hospital, but I couldn't stop shaking. He thought it was a better idea for him to drive me to the hospital. So we got out of my truck, ran over to his, and I was just shaking really bad. At that point, I told him, I think it's best if we call 911 because I didn't know what the damage was. I didn't know if it had gone under my skin. I didn't know. So we got on the phone with 911. I hear the sirens coming and I'm actually in the driveway on the phone with another contractor because this homeowner, his mom was 90 and she couldn't be out of power for more than one day because she had medical devices in her house. So I called another contractor, friend of mine. He came over while I was on my way down to the hospital and he actually finished the panel upgrade. He's an amazing contractor. I love the guy. So as I'm waiting for 911 to show up, they're on the phone with us. They're asking us, is the panel off? So I rush over there really quick, still shaking, go over there. I don't remember if the main breaker was on or off at that point. The ambulance showed up. They looked at my hand. They checked all my vitals. I was shaking still. They loaded me up in the ambulance. They drove me about 2 miles down the road to basically a parking lot is what it looked like. And I didn't understand what was going on. And then all of a sudden I heard the helicopter and they put me in a helicopter and flew me all the way down to downtown to the burn clinic. And I found out later that they don't mess around with electrical burns. They didn't know if it had gone through me. They didn't know anything. I get to the top of the roof at the hospital. They bring me down to the trauma clinic. There's like 15 people around me. They're saying, right hand, no exit wound. Left hand, no exit wound. Right foot, no exit wound. Apparently they were looking to see where the electricity went in and out of me. And I stopped them and I said, hey, what are you guys talking about? And they said, where did it come out of you? Where did it go in you and where did it go out of you? And I said, no. It was just an arc flash on my hand. And they said, oh, okay. After that, everything kind of calmed down. They were more worried that the electricity had gone through me and that it had burned through me. At that point, they sent me downstairs. After that, I was sent home and I was told to keep the burn completely wrapped. I had to put a cream on it every single day, 2 or 3 times a day, unwrap it, put more cream on, wrap it back up. It could never get the air is what they said. Do not let it dry out because it won't heal properly. So you can see again, this is what it looked like initially. My hand was completely charred. After about a week or 2, this is what it looked like. The skin completely separated from my hand. At this point, I was just waiting for all the skin to fall off. They said that this is what was gonna happen. It got charred, the skin bubbled off, basically a huge blister all over my hand, and then it fell off and it looked like this. At this point, I still had to keep cream on it all the time. I had to keep it wrapped up. A couple of my fingers actually went numb because I had the wrap around my hand all the way down my arm just to make sure that everything was completely covered. And then after that, this is what it looked like about 3 to 4 weeks in. It was finally healing up. New skin was coming in. I was out of the woods, as you say. That's the story. That's what happened. 120, 240. I know that we might think sometimes that it's not that high of a voltage, But I'll tell you what, this was not fun. It was not fun at all. I was out of work for at least an entire month. The ambulance cost me $2,200. Hospital bill was $5,000, and the helicopter ride was $70,000. I own Landers Electric, so I don't have any sort of workman's comp. I do have insurance, so thankfully I was able to talk to the insurance company. Everything was covered basically, except for about $400, but that could have been a whole lot worse. And more than that, if the explosion had happened at my face, I could be blind right now. It's definitely not something to mess around with. I just wanted to share that with you guys and let you know, don't mess around with 122/40. It can send a blast that will completely ruin your skin, mess you up, be out of work for a long time. I hope that that was informative and helps you to think twice before doing hot electrical work without the proper PPE on. Thanks so much. We'll see you soon.
So yeah, let's get started. Right here, electricians, you'll see this is the electrician administrative rules. This is going to go over the different administrative rules that the Texas Department of Licensing and Regulation has. We're going to go over here, as you see, the authority, who has the authority. We're going to go over different definitions that are pertained within this specific code here. We'll go over licensing requirements for applicants, examinations, general renewals, waivers of examination requirements, continuing education, documentation of required on-the-job training, licensing requirements for temporary apprentices, licensing requirements for emergency licenses, exemptions, insurance requirements, electrical contractors' responsibilities, electrical sign contractors' responsibilities, responsibilities of all persons performing electrical work, residential appliance installer contractor responsibilities, and so on. There's a lot of stuff we're going to cover. So let's go ahead and get started. Section 73.1 here, the authority. These rules are promulgated under the authority of Title 8 Occupations Code Chapter 1305 and Title 2 Occupations Code Chapter 1. One thing to note here is that the TDLR actually has committee meetings that you can watch. They host them on their website, and then they're also on YouTube. I've found that these videos, I've noticed that they listen to the community. There's people coming in and they talk about different things that have happened in their community in the state of Texas, and they allow people to talk to them. And you can watch these. Those can be good resources, and those are who we're talking about. Those are the committee members who have the authority here, who make the laws, who make the rules in the state of Texas for electricians. Definitions. The following words and terms, when used in this chapter, have the following meanings, unless the context clearly indicates otherwise. Assumed name, a name used by a business as defined in the Business and Commerce Code. Business affiliation, the business organization to which a master licensee may assign his or her license. An employee, an individual who performs tasks assigned to him by his employer. The employee is subject to the deduction of Social Security and federal income taxes from his pay. An employee may be full-time, part-time, or seasonal. Employer, one who employs the services of employees, pays their wages, deducts their required Social Security and federal income taxes from the employee's pay, and directs and controls the employee's performance. I'm not going to go through every single one of these. I think we can just pull out some of the important ones here. Electrical contractor, a person or entity licensed as an electrical contractor that is in the business of performing electrical contracting as defined by Texas Occupations Code. Master electrician, an individual licensed as a master electrician who, on behalf of an electrical contractor, electrical sign contractor, or employing governmental entity, performs electrical work as defined by Texas Occupations Code. Journeyman electrician, an individual licensed as journeyman electrician who works under the general supervision of a master electrician on behalf of an electrical contractor or employing governmental entity while performing electrical work as defined by Texas Occupations Code. You can see it there. Then we have electrical apprentice, electrical sign contractor, master sign electrician, journeyman sign electrician, residential wireman, maintenance electrician, electrical maintenance work. I think this would be good to define the replacement or repair of existing electrical appurtenances, apparatus, equipment, machinery, or controls used in connection with the use of electrical energy in, on, outside, or attached to a building, residence, structure, property, or premises. That's a long sentence. All replacements or repairs must be of the same rating and type as the existing installation. No improvements may be made that are necessary to comply with applicable codes under Texas Occupations Code Chapter 1305. Electrical maintenance work does not include the installation of any new electrical appurtenances, apparatus, equipment, machinery, or controls beyond the scope of any existing electrical installation. Electrical sign work, you guys know what this stuff is. Work involved in the manufacture or electrical equipment, electrical sign apprentice, on-the-job training, residential appliance installer. So if you ever need to know specifically what the TDLR is referring to when they define a term, this is where you go. They have electrician administrative rules, and you can find all those here. They're going to use some of these terms in the lower sections here. And so I think that's why they're defining this. We do the same thing in the National Electric Code, in NFPA 70E, safety. It's the same thing. So the first section here that actually gets into the rules is 73.20, licensing requirements, applicant and experience requirements. An applicant for a license must submit the required fees with a completed application and the appropriate attachments. Applicants for master electrician, master sign electrician, journeyman electrician, journeyman sign electrician, residential wireman, journeyman lineman, maintenance electrician, and journeyman industrial electrician licenses must submit documentation proving the required amount of on-the-job training. Applicants for contractors' licenses must submit proof of general liability insurance and either workers' compensation insurance or a certificate of authority to self-insure, or a statement that the applicant has elected not to obtain workers' compensation insurance pursuant to subchapter A, chapter 406 Labor Code with the initial and renewal applications. Number 3 here, applicants for contractors' licenses must submit proof of ownership of the business entity and provide documentation of the sponsoring master licensee in a manner prescribed by the department. Number 4, an applicant for a journeyman lineman license must submit documentation proving the required amount of training in an apprenticeship program or the requirement amount of experience as a journeyman lineman. An applicant must complete all requirements within 1 year of the date the application is filed. Each applicant must meet the applicable eligibility requirements as set forth in Texas Occupations Code 1305.153 through 1305.1618. The next section here, 73.21, licensing requirements having to do with examinations. The first section here, to obtain a license by examination issued under this chapter, an individual applicant must submit all completed application or a completed application, all necessary documentation, and appropriate fees to the Texas Department of Licensing and Regulation for review and determination of examination eligibility. Number 2, an individual applicant must achieve a passing score on an examination approved by the executive director of the TDLR. B, to obtain a license without examination, an applicant must have been licensed for the preceding year by a municipality or regional licensing authority that has terminated its licensing program and have applied for a state-issued license within 90 days of the date the program stopped issuing or renewing licenses. So for some reason, your region or municipality has terminated its licensing program, you're going to need to apply with another one. Section 73.22, licensing requirements general. A license issued under this chapter is valid for 1 year from the date of issuance and must be renewed annually. You all know that. That's why you're taking this course. A person shall not perform electrical work requiring a license under Title 8 Texas Occupations Code, Chapter 1305, with an expired license. C, falsifying information on an application, obtaining a license by fraud or false representation, or cheating on an examination is grounds for denial, suspension, or revocation of a license and or an administrative penalty. D, an electrical contractor, an electrical sign contractor, or a residential appliance installation contractor shall not use a license number that is not assigned to that contractor by the department. E, a license is not transferable. F, altering a license in any way is prohibited and is grounds for a sanction and or penalty. G, if a licensee contracts with a general contractor or a home warranty company to provide installation or service that requires a license under the Act, the licensee remains responsible for the integrity of that work. You guys get that one? So if you're a licensed contractor and you contract with a general contractor or a home warranty company and you provide installation, you are responsible for the integrity of that work. H, a person using the license of another person or allowing another person to use his license shall be subject to license denial, suspension, or revocation and or assessment of a penalty. The next section, 73.23, and I promise that this is going to get better. We have to get through this. We have to learn about these different codes. They want you to be reminded of this. So bear with me. We'll get into electrical safety and then we'll get into the fun stuff in the NEC at the end. Licensing requirements renewal, 73.23. Non-receipt of a license renewal notice from the department does not exempt a person or entity from any requirements of this chapter. B, a complete request for renewal must be filed on the form approved by the department and includes all required fees by the expiration date to maintain continuous licensure. C, applications not filed by the expiration date are considered applications for late renewal and are subject to late renewal fees. Some of you have already taken my course. You know, we try our best within 24 hours to get your continuing education processed. I know that some of you take the course right up until that date. Some of you have taken it right on that date. And I know that it's really important that you guys get it done so that you don't have to pay any late renewal fees. If I don't get the certificate of completion done and emailed to you within 24 hours, I will go in and go to the TDLR's website where I input that you have completed your course. And I will do that within 24 hours every time. So I think I've had one of you guys that I messed up on. And I think you paid first and then you finished your course like a month later. And it's best if you do them both at the same time. Take your course and then pay, because it can get mixed up in my email inbox. But for the most part, everything's been pretty seamless. So I just want you guys to know that I work hard at what I do. I do work a full-time job, but I'm trying to provide some really good continuing education for you guys. So just know that. And if for some reason it does fall through the cracks, you can always email me. You can find my email. There's a contact page there. Shoot me an email real quick and I'll get you guys handled. Where were we? We'll just do C again. Applications not filed by the expiration date are considered applications for late renewal and are subject to late renewal fees. D, licenses issued from a late renewal application will have an unlicensed period from the expiration date of the previous license to the issuance date of the renewed license. Electrical work that requires a license issued under this chapter shall not perform during the unlicensed period. Section 73.24, licensing requirements, waiver of examination requirements. An applicant who is licensed in another state that has entered into a reciprocity agreement with Texas regarding licensure of electricians, sign electricians, journeyman linemen, journeyman industrial electricians, or residential appliance installers may obtain an equivalent license in Texas without passing the examination, provided that All other licensure requirements are met as defined by the Texas Occupations Code. So this here, if you're coming from another state, I know there's a few of you who do have out-of-state licenses. You know that there's only certain states that are reciprocal with Texas, meaning California is not reciprocal with Texas. So the license that someone has, say in California, New York, they are not reciprocal. Other states, it's all different. Some states are reciprocal with other states, some states are not. So you just have to look into it. If you're coming from another state, you need to check to see if you might not have to take the exam. The exam, I believe, is 100 questions. I don't know if it's changed, and it's like something like 4 hours. So if you can get out of that, that's good. But you have to make sure you follow the TDLR's requirements there and fill out the proper application, show them the proper documentation from whatever state you're in. Next section here, B, the examination requirement is waived if, based upon acceptable proof, the executive director determines that the provisions of 73.21B are met. C, acceptable proof of an applicant's qualifications must be presented on a form prescribed by the department that, number one, certifies completion of the required hours of on-the-job training under the supervision of a master electrician or master sign electrician as appropriate, or number two, is completed by the municipality or region in which the applicant was licensed for at least 1 year. Next section, what we're doing right now, 73.25, continuing education. First section A, terms used in this section have the meanings assigned by Chapter 59 of this title unless the context indicates otherwise. B, for each renewal, an electrical apprentice, electrical sign apprentice, journeyman electrician, master electrician, journeyman sign electrician, master sign electrician, residential wireman, journeyman lineman, maintenance electrician, or journeyman industrial electrician must complete 4 hours of continuing education in, number one, the National Electric Code, as adopted under Title 8 Occupations Code 1305.101, or the current version of the National Electric Code as approved by the NFPA there, the National Fire Protection Association. What we're reading right here is this is what I said in the beginning. I have to cover the National Electric Code, state laws and rules, and safety here, as you can see, as defined in the National Fire Protection Association, NFPA 70E. I'm going to show you guys when we get into those sections, for $10 a month, $10 a month. I think they just changed it because a year ago, the NFPA, you could access the code online, which meant that you could access the code anywhere. But I believe that you still had to purchase the entire code book. Well, I just noticed last night that they changed it. It's $10 a month, and you actually get access to all of the NFPA's books. So you get the National Electric Code, NFPA 70, you get NFPA 70E, as well as a whole barrage of other books that they have. And it's all available online. You just go to their website. Anytime you need to look up a code, anytime you need to look up anything. So go there. It's nfpa.org, I believe, and look for, I forget what they call it. It's NFPA link, I think is what it's called. $10 a month. And you have access to all of that stuff. It's way cheaper than trying to purchase all of those books separately. So we're going to use that in those sections when we get to the next videos, kind of as a guide. We'll go through it. We're going to break down the NFPA 70E. We'll break down NFPA 70, the code book. We're going to go through Article 90, figure out what the code, I mean, as I was writing this course, I even learned stuff out of it. You're constantly going to be learning. You're never going to get to a point where you say, I understand the code completely. So it's going to be good. All right, C, in lieu of taking, this is good. This is really good for some of you guys. Not so good for my business, but good for you guys, and I want you to know it. In lieu of taking 4 hours of continuing education as required in 73.25B, an electrical apprentice or electrical sign apprentice may enroll in a department registered apprenticeship training program. I don't really care that it's not good for my business. What I care about is that you guys get into an approved apprenticeship program somewhere. I've heard that some are better than others. You just have to look out. You guys, if you're an apprentice and you really want to learn this trade, you really want to grow in your knowledge and make this a career, you got to get into some sort of apprenticeship program. I went to the Associated Builders and Contractors apprenticeship program. It was good. I've been in both the union and the non-union. I know there's a big argument about that. I'm not going to get into that here. I've seen both sides. Both of the apprenticeships are pretty comparable. Get into one that is, if it's in your area, I would say an ABC or a WICA, something like that. It might not be in your area though. At least get into some. For one, you don't have to take continuing education. You will once you become a journeyman or a master or you're an electrical contractor. But at least for your apprenticeship, you can get out of it. You don't have to take this course. Your hours in the apprenticeship count toward continuing education. So yeah, let's move on. D, in the case of a timely renewal, the continuing education hours must have been completed or enrollment must have occurred in a department registered apprenticeship training program within the term of the current license. For a late renewal, the continuing education hours must have been completed or enrollment must have occurred in a department registered apprenticeship training program within 1 year prior to the date of renewal. Section E here, a licensee may not receive continuing education credit for attending the same course more than once. Now, I want to be clear on this. Don't think that you guys can't come back and take my course again. Every single year, I have to resubmit documentation to the TDLR, and within that resubmission, it becomes a new course because I have to update the videos, I have to update the content. TDLR changes things in the electrician administrative rules. Every 3 years, they come out with a new code book. I believe it's also 3 years for the NFPA 70E. So there's always something changing. So you guys can come back to my course every year. So don't think, or someone else's. If you prefer someone else's course, you're able to learn better over there. 100%. Take that course. And as long as they made updates to it, they made changes. It's a brand new course number that I get from the TDLR every year. So you guys feel free. You can come back. Don't let that one scare you away saying, oh, well, I already took, so I can't do it. Just know that I create new courses every year. Sometimes they're not completely different, but they have updates in them. Every 3 years, when we get to the NEC portion, there's going to be changes, like major changes. So I just want you guys to know that so that you feel if you like this, you can keep coming back every year. If you don't, you can keep going back to whatever course you do find that works best for you. Section F here, a licensee shall retain a copy of the certificate of completion for a course for 1 year after the date of completion. In conducting any inspection or investigation of the licensee, the department may examine the licensee's records to determine compliance with this subsection. Just in case anything were to happen with the TDLR, perhaps they misplace it, something happens, make sure you keep a copy of the email that I send you that has the certificate of completion in there. All right, G, to be approved under Chapter 59 of this title, a provider's course must be dedicated to instruction in 1, the National Electric Code, 2, state laws and rules, 3, safety as defined in the National Fire Protection Association. We already went over this again or before. It looks like they just put it in here again. Section H, to register an apprenticeship training program with the department, a program must file a completed application in a form approved by the department. Number 2, provide proof to the department that the program is A, recognized by the Texas Workforce Commission or the Texas Higher Education Coordinating Board, B, registered with the United States Department of Labor, or C, a competency-based standardized craft training program that meets the training program standards of the United States Department of Labor Office of Apprenticeship, and pay the required application fee. This is something that I've been thinking about. I really enjoy teaching. I enjoy working. I enjoy electrical. I've built a career around it. It's taking care of my family. My wife's able to stay at home. One thing I do really want to do though, at some point, is open an apprenticeship program. I want to see you guys grow. I want to see you guys learn, and I want to learn. The best way I think to increase in your knowledge over the years is to be continually flooding yourself with information. I really like teaching National Electric Code classes. It keeps me sharp. It keeps me learning the code. And, that's one thing you guys really got to think about in your career. There's so many different things in the electrical industry. You apprentices, especially listen up here. The journeyman and masters, you guys probably know some of this stuff, but you apprentices, there's so many different avenues that you can take in the electrical industry. I mean, I thought that I'm going to be an apprentice and then I'm going to be an electrician and all I'm going to do is change out light switches and receptacles all day. That's not the case. I mean, we're there in the beginning of a project doing the underground, and we're there until the last device is put in, us and the plumbers. For one, the longevity of a career, being able to be on a project from the start to the finish. I mean, just think about the job security that has. You have drywallers, you have painters, you have concrete guys. Those trades, they're not there the whole time. Framers, they're not all there. They come in, they do their job, and then they're gone. And typically unless you're working for a smaller company, you're doing service work, you might not get to see this as much. But for the bigger contractors, I mean, you might be on a job with 90 guys, 100 guys working the metropolitan areas, Dallas, El Paso, Austin, all those areas. I mean, they're booming right now. And those areas, you're going to that's why I'm telling you guys to get into an apprenticeship program, because you're going to get the experience. You're going to get experience to learn so many different things. I prefer the commercial world. I prefer because there's so much more that we get to do. It's not that we're better or whatever. It's just there's so many different aspects to electrical installation that go on in a high-rise building, a hotel, a hospital, things like that. So you're going to get exposed to so many more things. And what I was saying was, not only can you be an installer, but you get to move from being an installer to possibly being a lead journeyman, and then a foreman, and then a general foreman. And then at that level, perhaps you want to move into the office, right? Perhaps you've learned the install side, you've ran a job, you ordering material, handling all of the day in and day out things that go with the people skills that you have to have. You get to learn all those things. You move from foreman to general foreman, and then you want to go into the office. You want to be a PM. You want to be an estimator. Perhaps you want to specialize. My career, I've really specialized in lighting controls, advanced lighting controls. We're installing N-Light systems, Lutron systems, Crestron systems, really diving deep into those things and understanding how they work. And your knowledge just grows exponentially as you have more experience. But that's not it, right? So you could be a field guy, you could be an office guy, you can go train at an electrical training center. You can start your own company. There's so many different avenues in the electrical industry. So if you're an apprentice, I would just encourage you. You don't know a whole lot. This is what I tell a lot of my apprentices. You don't know a whole lot, but don't be discouraged by that. You need to look at what you don't have, and you need to make up for it in other areas. Those areas: motivation, drive, walking fast. I mean, I can't tell you how many apprentices, even journeymen, are so lackadaisical at their job. They just walk around the job site like they could care less if they got fired on the spot. Don't be that guy. Make something of yourself. Be proud of the work that you're doing. And I'll tell you what, as a foreman, even as a lead journeyman, when I was a lead journeyman, when I saw an apprentice who showed me that motivation, that drive, that willingness to learn, showing up early, possibly staying late if it was necessary, within reason, right? When he showed me that was the type of person he was and he really wanted to learn, what do you think my response was? My response was one of, I'm going to teach this person. Don't be those, if that's who you are and you just want to skate by, you're going to struggle. you're going to struggle, but don't look at the electrical industry. I think there's so many kids these days who that they want to be a YouTube influencer, or they want to be something. They want the quick buck. They want to whatever it is they want to do. They have no idea the opportunity that they can have in a building trade. It is hard work, especially as an apprentice. I know it sucks. It's not fun. It's not something that I enjoy. You just got to do what you're told and show that motivation, show that drive, and you are going to excel in this field. I can't tell you, I had no idea when I first started that my career was going to take this direction and go this way, but it's been such a blessing. I'm so thankful for, what God has given me in this trade. My wife stays at home. I've already mentioned it. I get to provide for them. I get to come home and I get to tell them, hey, I built this today. Look at that building. We were just driving the other day. We got off the freeway. I was working on this guy's house, and simple spotlights outside. The guy it was a dog daycare, and the guy wanted these super bright LEDs. Well, I went to Home Depot, I went to Lowe's, I went to all these places trying to find some good lights, and there was nothing that I felt comfortable putting in, and they just seemed cheap, everything. So I went on Amazon and I found these 15,000 lumen fixtures, 2 of them for $60, and had to retrofit them to make it work, put it in, and got off the freeway yesterday and I checked it out and I saw the lights up, and the guy had actually put a sign for the dog daycare right under one of the lights, right as you come off the freeway. I was so stoked. My wife was like, you are such a dork. And I was like, well, this is fun. I love going back and looking at my work and being able to come home and tell my kids and drive around the city, drive down the freeway. Daddy's been in that building. Daddy's been in that building. Daddy's done that. Do you see those lights? Dad got to do that. I mean, that's what life is about. That's what our career is about. Just finding that pride and that self-satisfaction in what we're doing. So you guys who might be struggling out there, just keep going, show that motivation, show that drive. And I guarantee the trade has so many avenues for all different types of electricians. Sorry about that ramble. I get pretty passionate. I love what I do. It's a fantastic trade. All right. So next section here, a department registered apprenticeship training program must maintain the following documents for 24 months after a participant is no longer enrolled in the program. Participant program application, proof of participant's program completion, participant's leave of absence, resignation, or termination, and other documentation affecting participants' enrollment. J, a department registered apprentice training program must submit to the department documentation of required on-the-job training. Section here, A, an applicant for a license which requires on-the-job training under Occupations Code Chapter 1305 may verify that he or she has completed on-the-job training by submitting the department's experience verification form with the license application. B, when an applicant or the department requests verification of on-the-job training of an applicant from a licensee who is authorized by Occupations Code Chapter 1305 to verify on-the-job training, the licensee must provide the verification within 30 days of the request. The licensee must verify only on-the-job training within the licensee's knowledge. The licensee must verify the dates of on-the-job training, describe the work performed by the applicant, specify the name of the business under which the applicant's work was performed, and provide any other information required on the department's form. C, an applicant for a journeyman lineman license must verify that he or she has completed the apprenticeship required by Occupations Code Chapter 1305 by submitting verification in a form acceptable to the department. Next section, 73.27, licensing requirements having to do with temporary apprentices. An applicant for a license as an electrical apprentice or an electrical sign apprentice will be issued a temporary apprentice license if the applicant has not been convicted of a criminal offense and pays the required fees. And B, a temporary license is valid for 21 days and may not be renewed. Section 73.28, we have emergency licenses. The executive director may grant emergency electrician licenses when it's in response to an emergency, a state of disaster declared by the governor, the presiding officer of the governing body of a local governmental entity pursuant to Government Code 418-108, and the executive director determines that a sufficient number of persons holding electrical licenses recognized under Texas Occupations Code Chapter 1305 is not available to perform electrical work needed to timely respond to a disaster. There it shows how to obtain an emergency license if that happens. An emergency license will be classified as master, all the same ones. An emergency license will expire 90 days after issuance. And number one is valid only in the disaster area designated by the governor or in the jurisdiction of a local governmental entity declaring a disaster. Two, it's valid only during the time of that disaster. Number three, may be renewed for an additional 90 days if the disaster and any applicable recovery period continue on the 80th day of the emergency license. The executive director determines at the time that a sufficient number of persons holding electrical licenses recognized under the TOC, Chapter 1305, is not available to perform electrical work needed to timely respond to the disaster. And C, submits a completed renewal application on a form acceptable to the department along with appropriate attachment and the required fee. C, a person holding an emergency license must perform electrical work on behalf of an electrical contractor and in compliance with all applicable statutes, administrative rules, and ordinances. That's a given. The fee for emergency license will be the set amount of set out in 73.80 for the class of emergency license issued. Exemptions, next section. This chapter does not apply to electrical work as provided in Occupations Code Section 1305.003. Insurance requirements. Electrical contractors, sign, residential, installation contractors are required to maintain at least the minimum general liability insurance coverages at all times to satisfy proof of financial responsibility. You masters out there, you know this. It's very easy. You get it and you keep it. There's nothing special about that. These are the numbers that you have to have, the amounts. B, a licensed applicant or licensee shall file with the department a completed certificate of insurance or other evidence satisfactory to the department when applying for initial and renewal licenses and upon request of the department. C, proof of the required general liability and workers' compensation insurance can be submitted on an industry standard certificate of insurance form with a 30-day cancellation notice. Workers' compensation coverage may be established by a certificate of authority to self-insure, or an applicant may state that it has elected not to obtain workers' compensation coverage. We're going to skip to the next section. Electrical contractor's responsibilities. An electrical contractor shall notify the department when a new master electrician of record is assigned to the contractor and notify the department within 30 business days from the date that the master electrician's employment with the contractor ended. And two, they must maintain employee records and records of all work performed on its behalf for a period of 4 years after completion of the work, and shall make those records available to the department at the contractor's place of business during normal business hours for inspection and copying. If the contractor's principal place of business is located out of the state of Texas, the department may require the contractor to make records available to the department at its offices in Austin, Texas, or another location agreed upon by the department and the contractor. B, a person or contractor that performs or offers to perform electrical work shall provide safe and proper installation and service and assure the electromechanical integrity of all work and installations are to applicable code. This is big. This is really big. We need to make sure as electricians that when we are installing, that we do it proper, that we follow the codes, not because the inspector tells us to, but because safety is on the line. I mean, I know that we all don't love the safety guys who run around the job sites, right? But they are there to help protect us, right? If you're your own, let's say you own an electrical contracting company or you work in the service department and you're running around, you have got to make sure that I've seen things blow up. I mean, we've all seen it. You got to make sure that what we are installing is safe. I mean, that's the purpose of the code. We're going to get into that, Article 90, right? The purpose of the code is to make sure that we are installing things in a safe manner. It is a minimum safety standard. We have to be professional. We have to do it right. I could tell you story after story. I'm not going to go into it, but times when someone did something wrong, I know that accidents happen, but times when someone did something wrong, they didn't care, they walked away from it, and that thing blew up on somebody. That is not something that you ever want to have to deal with. I myself, I've ran into one circumstance. I'll tell one story. I was trying to offload a piece of gear off of a truck, a semi. We had ordered the piece of gear to come on a flatbed truck because it was really tall. Well, they sent it in an enclosed truck. We were really struggling to get it out because when we backed it, they literally had to push the thing in there, and it stretched the roof of the semi a little bit. So when the piece of gear popped in there, it came down over the back of it about 3/4 of an inch. So we couldn't get it out. It kept hitting the back. Well, I finally was able to figure something out of how to get it out of the truck. But the problem was in all the trying to figure it out, I forgot the number one thing. And what is it? Put a strap around it. I didn't do the simple task of put a strap around it. What happened? I actually wasn't driving the forklift. Somebody else was, thankfully. But I was still in charge. So I have to take responsibility for it. He backed out of the truck. The thing started tipping. A $33,000 piece of gear fell over on its side. I had to make the phone calls. It was a nightmare. Thankfully, we found a company that we sent it to, and they were able to refurbish it for $11,000. Whether that was okay or not, I mean, the customer was expecting a brand new piece of equipment. It got recertified and went through all the, UL, everything to make sure that it was up to standard, but it's not something you want to have to do. I actually had to teach. It was my first teaching gig. I had to go teach the forklift training class for our company that year. I was basically voluntold that that's what I needed to do. And so I ended up doing it, teaching safety on forklift. So that's about all the time we have for this section. I wanted to make one note on what I said before. I was saying commercial work is the best. It's not the best. There are plenty of residential contractors, residential electricians who are super sharp. I was thinking about it as we were going through it. I by no means was trying to say that. You can get a lot of experience in the residential world as well. My experience just came in the commercial world. So don't think that if you're in working resi right now, you're doing installs over there, that you're not learning anything. You have opportunities over there just the same in the commercial world. So I don't want by any means to push that off and say resi's bad, commercial's the best. You guys can go ahead and get in those conversations with each other. They're both good. We need to be professional in whatever we're doing, following the local codes, following the guidelines that the TDLR has outlined for us. You can see we're only halfway through this. There's a whole lot more to it. Perhaps the next course, we'll go through the second half. But the next video, do electrical safety. Let's go ahead and move on. All right, guys, here we are for lesson 2. As I said, we are going to move into electrical safety. I said in the last video that you can go to nfpa.org and you can download the link, NFPA link. Let's go there so you guys can see, have it saved. But you can go to this website and search up here, NFPA link. And we can find here in codes and standards. There it is right there. It's up at the top. NFPA link. You can try a 14-day trial, but that's what we're going to use to go through our electrical safety section. The TDLR wants us to use the NFPA 70E. The normal code book is NFPA 70, and NFPA 70E is safety, electrical safety. You can see electrical safety in the workplace. So we're going to use this as our guide to go through. We'll talk about electrical stories that might have happened. We'll try and break this down so you guys have an understanding of what this book is. Perhaps you've never even seen it. The National Fire Protection Association has come out with this to give us ways to stay safe while we're working. So we'll start off with the origins. This edition of NFPA 70E standard for electrical safety in the workplace was prepared by the Technical Committee on Electrical Safety in the Workplace and released by the Correlating Committee on National Electric Code. It was issued by the Standards Council on June 1st, 2020, with an effective date of June 21st, 2020, and supersedes all previous editions. This edition of NFPA 70E was approved as an American national standard on June 21st, 2020. This, what you are looking at, is the new 2021, as you can see it up here, NFPA 70E. I didn't know that it came out yet, but I went on here last night and they had come out with it. So that's what we're going to go over. The foreword, the Standards Council of the National Fire Protection Association announced the formal appointment of a new Electrical Standards Development Committee on January 7, 1976. The Committee on Electrical Safety Requirements for Employee Workplaces reported to the association through the Technical Correlating Committee on National Electric Code. The committee was formed to assist OSHA in preparing an electrical safety standard that would serve OSHA's needs and that could be expeditiously promulgated through the provisions of Section 6 of the Occupational Safety and Health Act. OSHA found that in attempting to utilize the latest edition of the NEC, it was confronted with the following problems. So what they're telling us here is that this book was created because the National Electric Code was not sufficient to provide electrical safety in the workplace. As you guys will see when we get to the National Electric Code section, the National Electric Code is a minimum safety standard for installing, how we do it, wiring methods, grounding, bonding, all of that stuff is in there. But that, what they're saying, was not sufficient to provide electrical safety in the workplace. So that's why this was created. Number one, OSHA could not adopt or modify a standard through procedures that provide for public notice, opportunity for public comment, and public hearings. The adoption of a new NEC edition by these procedures would require extensive effort and application of resources by OSHA and others. Going through the procedures might result in requirements substantially different from those of the NEC, thereby creating a conflict between the two standards. Number two, the NEC is intended for use primarily by those who design, install, and inspect electrical installations. Most of the NEC requirements are not electrical safety related work practices, electrical system maintenance, or directly related to employee safety. However, OSHA electrical regulations, which address employers and employees in their workplaces, needed to consider and develop these safety areas. It became apparent that a need existed for a new standard tailored to fulfill OSHA's responsibilities that would still be fully consistent with the NEC. So you can see this is working in tandem with it. They could not use the NEC, the NFPA 70 as an electrical workplace standard, so they created this. This led to the concept of a new document that would extract suitable portions from the NEC and from other documents applicable to electrical safety. So you can see there, they do use the NEC as somewhat of a guide, as well as other, perhaps they use ASHRAE and IESNA and, all lighting and whatever other documents they use. Perhaps it's in here and will explain it to us, what they use specifically, but that's kind of how this whole thing came about. This concept offered and an offer of assistance was submitted in May 1975 to the Assistant Secretary of Labor of OSHA, who responded as follows. The concept, procedures, and scope of the effort discussed with my staff for preparing the subject standard appear to have a great merit, and an apparent need exists for this proposed consensus document, which OSHA could consider for promulgation under the provisions of Section 6B of the Act. OSHA does have an interest in this effort and believes The proposed standard would serve a useful purpose. With this positive encouragement from OSHA, the NFPA electrical section unanimously supported a recommendation that the NEC correlating committee examine the feasibility of developing a document for evaluating electrical safety in the workplace. With recommendations from the electrical section and correlating committee, the Standards Council authorized the establishment of a committee to carry out this examination. This committee would develop a standard for electrical installations that would be compatible with the OSHA requirements for employee safety in locations covered by the NEC. The standard was visualized as consisting of 4 major parts. Pay attention to this. Part 1, installation safety requirements. Part 2, safety related work practices. Part 3, safety related maintenance requirements. And part 4, safety requirements for special equipment. It was not considered essential for all of the parts to be completed before the standard was published and made available. Each part was recognized as being an important aspect of electrical safety in the workplace, but the parts were sufficiently independent of each other to permit their separate publication. The first edition of NFPA 70E, Standards for Electrical Safety Requirements for Employee Workplaces, was published in 1979 and included only Part 1, Installation Safety Requirements. We're not going to read this whole thing. It goes into all the different publications and all of the different years, and we know they continually update. I believe that this one is also about every three years. Yep, the last one was 2018, and they just brought this one on in 2021. So that is kind of how the NFPA 70E came about. Now, the committee personnel. The National Electric Code itself is also broken down like this, and we'll go over it when we get over there. But the way it works is there is a committee that is over each section of the code. That committee oversees that section, and the way that it works is the public is allowed when they'll do an edit. So we just finished the one in 2021. They just released it to us. We can now read it. We can view it. This is the new standard that we as electricians have to go by. Employers have to go by this. When they start working on the next revision, each committee will look over their specific section that they are in charge of and make any changes or edits that they feel need to happen. And then what happens is they open that up to public opinion. So you, me, electricians, manufacturers, anybody can submit an actual, it's almost like a legal, you have to follow a specific parameter for it to actually be a response to how they changed the code. So they set it out, they let us all look at it, we can make comments on it, and then they go back and they review the comments on their specific section, and then the finalized publication comes out. Does that make sense? So here you can see you have all of these people who are a part of the committee for this specific book. This is the Technical Committee on Electrical Safety in the Workplace. There should be more down here. Anyways, Correlating Committee on the National Electric Code. The chair, Lawrence S. Iyer, and then all of the people who make up actually editing this and creating it and making sure that it stays up to date based on current, new technologies come out, new safety has to be implemented. That's the way it works. Introduction. So now we get into Article 90, not to be confused with NEC Article 90. They both have an Article 90. They both start just like this, 90.1, purpose. You would be surprised as to how many people have never read Article 90 of either the code and especially NFPA 70E. Right here in 90.1, it tells us the purpose of why this book is here. The purpose of this standard is to provide a practical, safe working area for employees relative to the hazards arising from the use of electricity. I'm going to read that again. The purpose of this standard is to provide a practical, safe working area for employees relative to the hazards arising from the use of electricity. Makes perfect sense. Section 90.2, scope. A, what is covered in this standard? This standard addresses electrical safety related work practices, safety related maintenance requirements, and other administrative controls for employee workplaces that are necessary for the practical safeguarding of employees relative to the hazards associated with electrical energy during activities, things that we do, such as the installation, the removal, the inspection, the operation, the maintenance, and demolition of electric conductors, electric equipment, signaling and communications conductors and equipment, and raceways. So basically all of the installations that we do are covered under the way to work safely within those installations is by following their guidelines. This standard also includes safe work practices for employees performing other work activities that can expose them to electrical hazards, as well as safe work practices for the following. 1, installation of conductors and equipment that connect to the supply of electricity. Number 2, installations used by the electric utility, such as office buildings, warehouses, garages, machine shops, and recreational buildings that are not an integral part of a generating plant, substation, or control center. Right here, something I want to show you guys, informational note. This standard addresses safety of workers whose job responsibilities involve interaction with energized electrical equipment and systems with potential exposure to electrical hazards. Concepts in this standard are often adapted to other workers whose exposure to electrical hazards is unintentional or not recognized as part of their job responsibilities. The highest risk for injury from electrical hazards for other workers involve unintentional contact with overhead power lines and electrical shock from machines, tools, and appliances. The first note on that, this is an informational note. This is not something that you can quote to an inspector. This is not a code itself. You cannot go in here and say, well, that informational note says this, so therefore I can install this way. It is just an informational note, and it is there just to provide extra information to help you understand the section that we just read before. Does that make sense? The second note on that is right here. The highest risk for injury from electrical hazards for other workers involve unintentional contact with overhead power lines and electric shock from machines, tools, and appliances. This goes back to what we said in the last video. They know, and we know, that electricity is dangerous. Overhead lines and everything with inside of a building. That is why we are going over this. This is why the TDLR finds that this is very important for us to go over. So don't think that you're sitting here wasting your time. We're going to go through this and you are gaining knowledge. You are going to gain some information. If not anything, at least that you're just exposed to this book and you know that it exists, so that if there is a situation that you run into where you don't know what to do, you don't know how to protect your guys, you don't know a certain procedure to follow, we can look here. They have done a very good job of trying to umbrella the entire electrical industry using the NEC, using other resources, umbrella the entire thing with a way that we can work safely. So this is a very good resource for us. B, A was what is covered in the code. B, what is not covered in the code. This is important as well. This standard does not cover safety-related work practices for the following. There is a very closely aligned statement like this in the NEC. You're going to see that when we get into it. What is covered and what is not covered. They want to be clear, not only what they are covering, but what they are not covering. This standard does not cover safety-related work practices for the following: installation in ships, watercraft other than floating buildings, railway rolling stock, aircraft, or automotive vehicles other than mobile homes and recreational vehicles. It also does not cover installations of railways for generation, transformation, transmission, or distribution of power used exclusively for operation of rolling stock, or installations used exclusively for signaling and communication purposes. Number three, it does not cover installations of communications equipment under the exclusive control of communications utilities, AT&T, Cox, whoever you have, located outdoors or in building spaces used exclusively for such installations. The cable box you have outside your house, they are not covering that in this. This is not for electrical safety for low voltage cable work outside. This is key. This is another thing I want to point out before we get too far. You have got, when you go through the codes, both in the NFPA 70E and in NEC, you have got to make sure that you pay attention to the wording. You need to become very legal. All of the terms in here, it can be very, anybody who's taken their journeyman license or their master's license understand it's the way that they word the code sometimes can be very difficult. But it's imperative that you spend the time, read it, and fully understand what is being said in each passage, each section. Number four, installations. It is under the exclusive control of an electric utility where such installations consist of service drops or service laterals and associated metering, or are located in legally established easements or right-of-ways designated by or recognized by public service commissions, utility commissions, or other regulatory agencies having jurisdiction for such installations, or are on the property owned or leased by the electric utility for the purpose of communications, metering, generation, control, transformation, transmission, or distribution of electrical energy, or are located by other written agreements either designated by or recognized by public service commissions, utility commissions, or other regulatory agencies having jurisdiction for such installations. These written agreements shall be limited to installations for the purpose of communications, metering, generation, control, transformation, transmission, or distribution of electrical energy where legally established easements of right-of-ways cannot be obtained. These installations shall be limited to federal lands, Native American reservations through the U.S. Department of the Interior, Bureau of Indian Affairs, military bases, lands controlled by port authorities, and state agencies and departments, and lands owned by railways. Again, these are all areas that were not covered by NFPA 70E. 90.3, standard arrangement. This standard is divided into the introduction and 3 chapters as shown in figure 90.3. Chapter 1 applies generally. Chapter 2 addresses safety-related maintenance requirements, and Chapter 3 supplements or modifies Chapter 1 with safety requirements for special equipment. Again, Chapter 1 applies generally to all installations. Chapter 2 addresses safety-related maintenance requirements specific to maintenance, and Chapter 3 supplements or modifies Chapter 1 with safety requirements for special equipment. So you're going to have in Chapter 1 your general overview, and you will see as we go through references to Chapter 3. Chapter 3 modifies those. It can enhance the safety in specific situations. Informative annexes are not part of the requirements of this standard, but are included for informational purposes only. So that's another thing. Excuse me. That's another thing that we have: the informational notes that cannot be quoted, that are there for informational purposes. And we also have the informative annexes. Both of those are not part of the requirements, but they are included for informational purposes only. All right, so here we see what we just read kind of broken down. So for you visual people out there, this is very helpful. Got your introduction, introductory and explanatory material, what we're going through, Article 90, Chapter 1, safety-related work practices. Chapter 2, safety-related maintenance requirements. Chapter 3, safety requirements for special equipment, and informative annexes. And you see here, Chapter 1 applies generally to electrical safety in the workplace. Chapter 2 addresses safety-related maintenance requirements. Chapter 3 modifies the general requirements of Chapter 1. And the informative annexes, informational material only, not mandatory. 90.4. Mandatory rules, permissive rules, and explanatory material. Here we're going to get a little deeper into how the code is laid out. Mandatory rules. A, mandatory rules of this standard are those that identify actions that are specifically required or prohibited and are characterized by the use of terms shall or shall not. We will see that as we get in. It will say you shall not do this. You shall do this. Those are mandatory. There's no exceptions to that. Permissive rules. B, permissive rules of this standard are those that identify actions that are allowed but not required, are normally used to describe options or alternative methods, and are characterized by the use of the term shall be permitted or shall not be required. C, explanatory material. Explanatory materials such as references to other standards outside of this code, references to related sections of this standard, or information related to a rule in this standard is included in this standard in the form of informational notes right here. Such notes are informational only and are not enforceable as requirements of this standard. Brackets containing section references to another NFPA document are for informational purposes only and are provided as a guide to indicate the source of the extracted text. These bracketed references immediately follow the extracted text. Right here, we see an informational note as an example. The format and language used in the standard following guidelines established by NFPA and published in the National Electric Code Style Manual. Copies of this manual can be obtained from NFPA. Again, nfpa.org. You can go there. You can get the link. I love it. It's fantastic. $10 a month. I spend more than that at McDonald's nowadays. D, informative annexes. These are non-mandatory information relative to the use of this standard is provided in informative annexes. Informative annexes are not part of the requirements of this standard, but are included, again, for informational purposes only. So, and the last section here in Article 90 is 90.5 formal interpretations. To promote uniformity of interpretation and application of the provisions of this standard, formal interpretation procedures have been established and are found in the regulations governing the development of NFPA standards. So what they're saying in that last section, formal interpretations. Let's say you're on a job and you don't understand a code, something, a safe work practice, something's going on, you don't know one way or the other what to do. So you come to NFPA 70E, you look that up, you find it, but you still kind of don't understand what it's saying. Well, what you can do is NFPA has a place where you can submit what they call a formal interpretation. And that that question, it's a question asking, can you help me interpret this? Interpret this. Help me understand what this means more. That email, if you do it in the right place, you can't just shoot off an email to NFPA, info@nfpa70e.com or whatever. You can't do that. You have to actually go through a formal process. And that will actually go to one of the members of the committees that we were talking about earlier. And they will actually look it over, read, and help you understand, and they will respond to that in a formal response. So you can get, and that formal response can help you in the event, like when we get to the NEC portion, say you're there with an inspector, you differ on something. You can bring that and show that to the inspector. Now, whether or not the inspector listens or not, that's really up to him. I mean, he's the authority having jurisdiction, the AHJ. He's the one who has the final say, but it's worth a shot. And really, just for your own information, if you don't understand something and you want to learn it, you can send that into them and they will help. It's a fantastic resource to have. We go back. Now we get into chapter 1, safety-related work practices. Here we see the breakdown. We have Article 100, definitions, Article 105, application of safety-related work practices and procedures, Article 110, general requirements for electrical safety and safety-related work practices, Article 120, establishing an electrically safe work condition, Article 130, work involving electrical hazards. I keep reminding you of this, but the NEC has Article 100. It has some of the same article numbers. Do not, get them confused. Article 100 definitions is also Article 100 definitions in the NEC. Article 90 introduction is also Article 90 in the NEC introduction. So just make sure that you get it in your mind. These are two separate documents. One having to do specifically with safety, the other having to do with a minimum safety standard for our installations. All right, Article 100, definition, scope. You'll see at the beginning of every single article in both NFPA 70E and in NFPA 70, which is the NEC, scope. It lets us know what this article is about. This article contains only those definitions essential to the proper application of this standard. It is not intended to include commonly defined general terms or commonly defined technical terms from related codes and standards. In general, only those terms that are used in 2 or more articles are defined in Article 100. Other definitions are included in the article in which they are used, but may be referenced in Article 100. The definitions in this article shall apply wherever the terms are used throughout this standard. Accessible, as applied to equipment. Definition, admitting close approach, not guarded by locked doors, elevation, or other effective means. Why is this important? Well, we'll see. We have certain circumstances where you're not allowed to install a certain device in a place where it is not accessible, right? Well, what does accessible mean? That's up for interpretation. Well, what they're trying to do is limit that interpretation to this definition. Admitting close approach, not guarded by locked doors, elevation, or other effective means. That's how all of these are. Approved, acceptable to the authority having jurisdiction. It is an approved standard. Arc flash hazard, a source of possible injury or damage to health associated with the release of energy caused by an electric arc. How many of you guys have seen videos of an arc flash? We've all seen them. I saw one video where the guy was standing in front of a piece of gear, super sad video, blew up 2,000 or 3,000 amp gear, the guy disappeared. Again, safety, safety, safety. That is the purpose of this. I mean, we've all watched the electrical fails videos where You know, you got the bird that flies into the power lines, or the cat that's up on the line, or whatever it is. Transformers blowing up, power packs blowing up. You know, that is why we're going through this, so that these things don't happen. No arc flash. We don't need any of that. Arc flash suit. I don't know how many of you guys have used one of these. Certain arc flash suits have different ratings depending on the voltage that you're using. A 120, 208 system has a different rated suit than a 277, 480 system, and higher, 12 kV, all those things. We have to make sure that when we are working on energized equipment, which should be a minimum, that we have to do that. Don't be lazy. Find the breaker, shut it off. But in certain circumstances, we're working in live facilities. We're working in a scientific laboratory where they have live experiments going on, you know, and they can't shut the power off to any of this stuff. We have to work. They have to work hot with the system energized. We have to then take the safety measures and make sure that we follow the proper steps to be safe in that situation. An arc rating. This is what I was talking about. You have to have a suit that is rated for whatever the arc rating is of that electrical system. The value attributed to materials that describes their performance to exposure to an electric arc discharge. The arc rating is expressed in cals per centimeter squared and is derived from the determined value of the arc thermal performance, ATBV, ATPV, or energy of break open threshold, should a material system exhibit a break open response below the ATB value. ATPV. Arc rating is reported as either ATPV or EBT, whichever is the lower value. Again, we have some more informational notes here. We don't need to go into all of those. Attachment plug, a device that by insertion in a receptacle establishes a connection between the conductors of the attached flexible cord and the conductors connected permanently to the receptacle. AHJ, this is what I was talking about earlier, the authority having jurisdiction. This might be a city inspector, this might be a county, this might be a federal inspector. The military jobs, they all have different types. I was working on a high-rise, a military high-rise, and it was not a city inspector. It was actually pretty funny because the guy never had done a commercial building ever. So we really had the opportunity to take advantage of him if we wanted to, because he had no idea what he was looking at. We didn't. Again, it goes back to professionalism and installing things according to how the NEC and how NFPA 70E tell us to. You can try and get away with things. It's going to come around and bite you at some point. So again, authority having jurisdiction is the organization, office, or individual responsible for enforcing the requirements of a code or standard, or for approving equipment, materials, and installation or a procedure. Informational note here, the phrase authority having jurisdiction, or its acronym AHJ, get that in your mind. AHJ, AHJ, they are the ones who have the authority. These are the guys and the women who you want to make friends with. You do not want them to be upset with you. They can make our lives very, very difficult by nitpicking minor things that they typically wouldn't. You know, one of the things that I strive to do in my electrical installations is to get it right the first time. Because you get an inspector out there and you have a bad installation, and it's not just that one inspection that he's going to be looking out for you. He's going to be looking at every single inspection that you ever have in the future. Foreman, general foreman, business owners, we all know this. It is not something that we do not want to get them on our bad side. So sometimes they'll come out and they'll have these pet peeves, you know, one little thing that they always want to focus on. At that job that I was at, the guy didn't want any of the MC sitting on top of the ducts. That was it. He didn't care about the strapping. I mean, as I was walking with the inspector, I noticed sections of MC that were 16 feet long that didn't have a strap on. And I'm sitting there fuming inside of myself because I'm walking with the inspector and my guys didn't follow proper, simple strap your MC. He looked right at it, turned around, went around the corner, found a piece of MC that was laying on top of the duct and called us on that one. So again, some inspectors, they call them triple threats. Some of them are, they look at electrical, mechanical, and plumbing. They look at all of them. So they're not specific to one trade. But still, we want to make sure we're installing in a proper manner. Automatic, performing a function without the necessity of human intervention. Balaclava, an arc-related head protective fabric, that protects the neck and head except for a small portion of the facial area. That's what we put on when I'm putting an arc flash suit on. Every single arc flash suit bag should have this fabric in it. You pull it over your head, then you put the hard hat with the mask over it, you put your suit on, and you go do your work. A barricade, a physical obstruction such as tapes, cones, or A-frame type wood or metal structures intended to provide a warning and to limit access. We've all seen these. You got them on roofs, 6 feet, 16 feet in some locations away from the edge. It could be cones, delineators. They could weld up some L metal and put some aircraft cable through it. There's tons of different ways that we have barricades. And it's simply there to provide a warning to us to help us understand, hey, don't go in this area. Red tape, where I'm working, yellow tape is you can cross it. Red tape, do not go in. You're supposed to put a sign up, put your phone number on it. If that is your area, if you put red tape up, and then people are not allowed to walk into that space, they have to call that phone number and they have to get in touch with you and you have to give them the approval. I've seen guys kicked off of jobs because they crossed these sections that they're not allowed to go into. Don't do it. If you see a barricade, stay away from it. Barrier, a physical obstruction that is intended to prevent contact with equipment or energized electrical conductors and circuit parts. We have tons of these. Dead front covers, panel covers, transformer covers, all whatever it is, a simple 4S blank cover, right? It's trying to protect people from energized electrical conductors and circuit parts. Bonding, connected to established electrical continuity and conductivity. Bonding conductor or jumper, a reliable conductor to ensure the required electrical conductivity between metal parts required to be electrically connected. Arc flash boundary, limited approach boundary, building, cabinet, circuit breaker, conductive, conductor bear. I'm not going to go through every single one of these. We're getting close to the end of this video. We got about 10 minutes left. So I want to move on to the next sections. But if you have any questions while you're going through the code as to what a specific word means, you can go back to the definitions, look it up, and you should be able to find an answer. Article 105, application of safety-related work practices and procedures. 105.1, scope. Again, the scope. It's letting us know what this is covering. Chapter 1 covers electrical safety related work practices and procedures for employees who are exposed to an electrical hazard in workplaces covered in the scope of this standard. 150.2, the purpose. These practices and procedures are intended to provide for employee safety relative to electrical hazards in the workplace. 105.3, responsibility. Both employers and employees have responsibilities. The employer shall have the following responsibilities: establish, document, and implement the safety-related work practices and procedures required by this standard. Number 2, provide employees with training in the employer's safety-related work practices and procedures. Those are the employer's requirements. Employee, you also have a responsibility. The employee shall comply with the safety-related work practices and procedures provided by the employer. We've all heard it. Everybody is a safety officer. Our employers establish these rules and we need to follow them. Hopefully, the employers have looked at NFPA 70E, or they have found some sort of training resource that they can provide to you as an employee, that you can take the course, whatever it is that they want you to do, take the course, learn the material, make sure that you go home at the end of every day to go see your families, or if you're single, just go home. Make sure you go home at the end of the day. That we want to work safe. We want to make sure that we're making it home and that we can show up the next day and don't have to deal with any type of issues as far as electrical safety is concerned. 105.5 organization. Chapter 1 of this standard is divided into 5 articles. Article 100 provides definitions for terms used in one or more of the chapters of this document. Article 105 provides for application of safety-related work practices and procedures. Article 110 provides general requirements for electrical safety-related work practices and procedures. Article 120 provides requirements for establishing an electrically safe work condition. Article 130 provides requirements for work involving electrical hazards. That's what's in this article. Let's go back. Next section, 110. General requirements for electrical safety-related work practices. 110.1, priority. Hazard elimination shall be the first priority in the implementation of safety-related work practices. That is what we're here for. That is what this book is for, to eliminate hazards, and that needs to be the first priority of every single one of us, whether you're an employee or an employer. 110.2, general. Electrical conductors and circuit parts shall not be considered to be in an electrically safe work condition until all of the requirements of Article 120 have been met. Safe work practices applicable to the circuit voltage and energy level shall be, again, look at that, shall be used. That's what we're talking about. This is mandatory. Safe work practices applicable to the circuit voltage and energy level shall be used in accordance with Article 110 and 130 until such time that electrical conductors and circuit parts are in an electrically safe working condition. That could be that they are locked out and tagged out, right? That could be that they're completely demoed out. Whatever it is, we need to follow what this is saying in both articles, all 3 articles, 120, 110, and 130. 110.3, electrically safe work condition. Energized electrical conductors and circuit parts operating at voltages equal to or greater than 50 volts shall be put into an electrically safe work condition before an employee performs work if any of the following conditions exist. The employee is within the limited approach boundary. And number 2, the employee interacts with equipment where conductors or circuit parts are not exposed, but an increased likelihood of injury from an exposure to an arc flash hazard exists. Electrically safe work condition. Energized work. Additional hazards or increased risk. Energized work shall be permitted where the employer can demonstrate that de-energizing introduces additional hazards or increased risk. Sometimes turning the power off causes more hazards than leaving it on. That's what this is saying. That is when we have to put a hot suit on. That is when we have to create a MOP, a method of procedure, some way, sit down, have a meeting. I've worked on live gear. We were installing a big LI switch. It's a big disconnect basically for high voltage. And we could not shut off that building. It was a government facility. It was classified information in there. They had a lot of stuff going on. We could not shut that off. So we had to tap that bus hot. And it's a scary thing to do. We sat down, we discussed the entire thing. We worked through the entire MOP, came up with that procedure, and executed it. And everybody was safe. Everything was good to go. There's obviously costs involved in that, but hopefully you employers are able in your estimating to assess those issues and put a price in there for that. B, infeasibility. Energized electrical work shall be permitted where the employer can demonstrate that the task to be performed is infeasible in a de-energized state due to equipment design or operational limitations. This is what I was talking about before. We're in some facilities. They have live experiments going on. Some of these experiments go for 5 years at a time, and we cannot shut the power off. So we have to do that work hot. Again, come up with an MOP, create safe work practices, get the right environment, follow the guidelines, and work safely. C, equipment operating at less than 50 volts. Energized electrical conductors and circuit parts that operate at less than 50 volts shall not be required to be de-energized where the capacity of the source and any overcurrent protection between the energy source and the worker are considered, and it is determined that there will be no increased exposure to electrical burns or to explosion due to electric arcs. So we see that less than 50 volts, as long as we follow the parameters, we can do energized electrical work on that. But don't let that fool you. You can still blow fuses. You can still incur cost because you put the wires together. We can set off fire alarms. We can do all that stuff. So you still need to be cautious when you're working on those systems. And most importantly, understand what you're working on. In our office, we were installing one of those Nest thermostat things. And the PMs in there were trying to do it. And I was in there watching them. And they actually tied all the wires in and ended up blowing a fuse because they didn't read the instructions. They didn't know how to install it. And it said right in the instructions that they needed to just take a jumper out of the Nest thermostat if it was a certain installation. And that's actually what it was. So it ended up blowing that fuse. I think it cost them 12 hours of getting a low voltage service guy out there. They had to find the fuse. It was not a normal fuse that you can just order. They just didn't know what they were doing. So understand what you're installing. That's really key number one to be safe, is understand what's going on. Next, normal operating condition. D, normal operation of electric equipment shall be permitted where a normal operating condition exists. A normal operating condition exists when all of the following conditions are satisfied. The equipment is properly installed. The equipment is properly maintained. The equipment is used in accordance with instructions included in the listing and labeling and in accordance with the manufacturer's instructions. The equipment doors are closed and secured, and all equipment covers are in place and secured. There is no evidence of impeding failure. And the last section that we'll be able to cover today, again, I'm going to try and, as I create more courses throughout the next couple of years, go through the rest of these videos so you guys will have them. But again, I just want to reassure you, you can take the course year over year. I provide updates to the course. You just can't get credit for the same course twice in 1 year. Not that you would try and do that, but that's what it's there for. So 110.5 electrical safety program. A, general, the employer shall implement and document an overall electrical safety program that directs activity appropriate to the risk associated with electrical hazards. That is all we got for this video. Again, we got 2 more. You're almost there. There's going to be 2 more attendance verification questions. Super simple. Answer those real quick and let's go on to the next one. All right, guys, we are halfway there. We are going to start our next section, which is going over the National Electric Code. This book is our pride and joy, or maybe it's not. Maybe you have absolutely no idea how to navigate this book. Maybe you have barely seen it 1 or 2 times in your career. Maybe you're brand new, or maybe you know it in and out. Maybe you teach on the NEC. Either way, it's going to be good for us to go back to the beginning. We're going to start again with the origins, that go over the committee personnel, the introduction, chapter 1, chapter 2, 3, 4, 5, 6, 7, 8, 9, and then the informative annexes. And as promised, I have a little something special. I'm going to take you guys into a building that we just finished and apply some of the codes in there and kind of walk through how we did an entire lighting retrofit in a building. I want to explain the lighting control system that we used. I want to explain the parts and pieces, how it works, and help you guys out just to kind of see. I'm sure some of you guys, I know that these products are being used all throughout many different states. We got different lighting control systems like Enlight, Lutron, Crestron, Green Gate. Then you got your ETC, your DMX, the color changing lights. You got so many different types of lighting control systems, and that's really where I have focused for the past 5-6 years of my career. So I want to kind of help you guys out with some good lighting knowledge, lighting installation knowledge. We'll go over some motion sensor stuff, but we're going to start with the code book, and I want to give you an overview, excuse me, of that, and then we'll kind of move into the lighting, and we'll kind of integrate the NEC into it. So without further ado, here we go. NFPA, excuse me, NFPA 70, also known as the NEC, the National Electric Code. This code is adopted in almost all 50 states. It is not a federal document. It is not mandatory for every single state, city, municipality, county. Some use it, some don't. Some use portions of it, some don't. So this was created by the National Fire Protection Association, as we'll see. The origins of this book, that this edition of NFPA 70, the National Electric Code, was prepared by the National Electric Code Committee and acted on by NFPA at its June Association technical meeting held June 17th through 20th, 2019 in San Antonio, Texas. It was issued by the Standards Council on August 5th, 2019, with an effective date of August 25th, 2019, and supersedes all previous editions. Again, we know that the code has been here for a long time. We'll see that when we get into the history and development. This code was issued with tentative interim amendments that impacted provisions in 210.52, 240.67, 240.87, 725.121, and Annex D3. Subsequent TIAs on 356.10, 551.71, 800, 100, 225.30, 716, and Table 16 have been issued and incorporated into the code. For more information, you can go see their website and check that out. This edition of the NFPA 70 was approved. This is the 2020 code as an American national standard on August 25th, 2019. But remember, not everybody adopts it. Some states are years behind the 2020. Some states are really close. Some states are on the 2017 right now. Some states are in the process of adopting the 2020. So it's really up to the governing agency, whether that, again, that's the city, the county, the state, to say, yes, we want to adopt this as our standard across the board. History and development of the National Electric Code. The National Fire Protection Association, the NFPA, has acted as sponsor of the National Electric Code since 1911. The original code document was developed in 1897 as a result of the united efforts of various insurance, electrical, architectural, and allied interests. I remember I got to see a really early version of the code. Our training center was getting rid of a whole bunch of books, and our training center has been around for a long time. And I forget what year it was, but it was a really early edition, and it was about this thick, super small, only like this big. And it was, you could just tell, it was pretty cool to see such an old, and to see where we have come from then as electricians. In accordance with the regulations governing the development of NFPA standards, a National Electric Code first draft report containing the proposed amendments to the 2017 National Electric Code was published by NFPA in July 2019. Again, this book is almost exactly the same in as far as we're discussing how it comes about and how the edits are made, how the committees oversee that, and then public comments are allowed to be inputted, and then they make the final revisions before their final publishing of the actual code. This report recorded the actions of the various code-making panels and the correlating committee of the National Electric Code Committee on each public input and first revision that had been made to revise the 2017 code. The report was published at nfpa.org following the close of the public comment period. That's what we were talking about. The code-making panels met, acted on each comment, and created some second revisions, which were reported to the correlating committee. NFPA published the National Electric Code second draft report in April of 2019, which recorded the actions of the code-making panels and the correlating committee on each public comment on the National Electric Code Committee's first draft report. The National Electric Code's first draft report and the National Electric Code second draft report were presented to the 2019 June Association technical meeting for adoption. So again, that's how it works. Each committee is over their specific section of the code. Public comments come in, they look at it, and they make revisions if they deem them necessary. You can see here, this is the 55th edition. First printed edition was in 1897. That might be one of the attendance verification questions on the next, as soon as we finish this video. 1897. That might be important to remember. This code is purely advisory as far as NFPA is concerned. It is made available for a wide variety of both public and private uses in the interest of life and property protection. These include both use in law and for regulatory purposes, and use in private self-regulation and standardization activities such as insurance underwriting, building and facilities construction and management, and product testing and certification. Committee personnel. We're not going to read all these, but again, here's the breakdown. Here's the chair, Michael J. Johnston. You might even see some people you know in here, depending on who you work for. It's a lot of different people. You can become a member to be on one of these committees. You see here, this guy's in the IBEW. We got IEC here, American Chemistry Council, Schneider Electric, Electric Light and Power Group. There's tons of them, tons of people, and they oversee all the different sections. This is much bigger because the code, the NEC, NFPA 70, I keep saying that so that you remember, NFPA 70 is the NEC. NFPA 70E is electrical safety in the workplace, okay? NFPA 70 is the NEC. Got it? That might be important to remember too. Maybe that'll be our second question. Voting alternatives. So some of these are voting members, some of them are non-voting members. AES Engineering, the chair for the code making panel number 2. You can see it here. This is the second code making panel. This is what they're in charge of. Articles 210, 220, Annex D, examples D1 through D6. That is what this group of people are in charge of. The next section, code making panel number 3. They're in charge of these sections. Does that make sense? You guys following me on that? The chairs, IEC. Let's see some companies out here. Automatic Fire Alarm Association, NEMA. NEMA's on here. Cisco. ABC right here. Associated Builders and Contractors. He's a representative from them. IAEI, the International Association of Electrical Inspectors. If you guys have never heard of them, they actually come out with a book that is all of the code changes, every single one of them. Every time there is a code cycle change, they come out with a new book. And that book is absolutely fantastic. It has every single change in the National Electric Code for that code cycle. I have the one for the 2020 edition. It's fantastic. I would encourage you guys, pick that up. People in the electrical industry, if you want to learn those things, you can get that book. Travelers Insurance Company, CME Consulting, alternates. These are alternates in case these people are not available, and so on. You guys can see that code making panel 4, 5, 6, 7, 8, all of that, all those guys. Introduction, Article 90. Again, we talked about this over in NFPA 70. E, it's the same thing. It's going to look really close. There's some extra stuff on this. I actually wrote an article on this and made it free to everybody so that they could read this. This is a very important. This is why the code is here. This gives us the exact reason why it exists, what it covers, what it doesn't cover. We'll go through a couple of these. We're not going to go through the entire thing, but 90.1 purpose right here, practical safeguarding. The purpose of this code is the practical safeguarding of persons and property from hazards arising from the use of electricity. Sounds very familiar to the other one. This code is not intended as a design specification or an instruction manual for untrained persons. 99% of the stuff that is in this code book, if you were not an electrician, it would be very difficult for you to understand. You might understand the words, the grammar, things like that, but the actual application of the particular code reference that you're looking at, you're going to really struggle to understand it. Really, my understanding of the code has grown as my experience in the trade has grown. Does that make sense? Because the more we're exposed to, obviously, the more times we go to the code book, the more things that we're exposed to and experience we're able to actually apply when we go into this book. So when I was a first year, I had no idea what was going on. Now being 13 years into the trade, having had to deal with swimming pools and swim up bars in casino pools and low voltage that was designed to be over a pool. And I mean, there's so many things that happen throughout our careers that cause us to increase in our knowledge in the code book. I say that so that you guys don't feel like you're miles behind. I have tons to learn still in the code book. I haven't experienced even a quarter of all of the stuff that's in here. And each and every one of us probably has different experiences with different areas of the code book, right? Residential guys, commercial guys, industrial guys, linemen, whoever it is, maintenance electricians, service electricians, you know, we all have different experiences. And so we're going to see the code from a different light. But this Article 90 is very important for all of us, no matter what areas of the code we specify in more. So adequacy. This code contains provisions that are considered necessary for safety. Compliance therewith and proper maintenance result in an installation that is essentially free from hazard, but not necessarily efficient, convenient, or adequate for good service or future expansion of electricity. Okay. C, relation to other international standards. The requirements in this code address the fundamental principles of protection for safety contained in Section 131 of International Electrotechnical Commission Standards 60364-1 electrical installations of buildings. 90.2 covered. We're going to see what's covered and what's not covered. Right here, well, let's get there. This code covers the installation and removal of electrical conductors, equipment, and raceways, signaling and communications conductors, equipment, and raceways, and optical fiber cables for the following. Number 1, public and private premises, including building structures, mobile homes, recreational vehicles, and floating buildings. Again, this is a list of what is covered. Number 2, yard lots, parking lots, carnivals, and industrial substations. Number 3, installation of conductors and equipment that connect to the supply of electricity. Number 4, installations used by the electric utilities, such as office buildings, warehouses, garages, machine shops, and recreational buildings that are not an integral part of the generating plant, substation, or control center. Number 5, installation supplying shore power to ships and watercraft in marinas and boatyards, including monitoring of leakage current. And number 6, installations used to export electric power from vehicles to premises wire or for bidirectional current flow. These are all things that are covered in this code. Now, you can probably barely see it. You're going to have to zoom up maybe, but you can notice that these two, number 5 and number 6, are highlighted. There's a pink background there. What that is showing us in this particular code is that those are changes from the 2017 code to the 2020 code. These two sections were not there before, and they are there now. This is imperative. If you have a hard copy, they usually put a gray highlight around these sections if they were changes. Here online, they put a pink background. Excuse me, my voice is going out. So that's important for you guys to understand. And then right here, this is fantastic on the online version of the code. They have this enhanced content that helps us to understand these sections even more. This is absolutely fantastic to have. I mean, illustrations in here. It's great. I mean, you can buy the illustrated guide to the NEC, but to have this online on your phone, it's just fantastic. B, not covered. This code does not cover the following: installations in ships, watercraft, other than floating buildings, railway, rolling stock, aircraft, or automotive vehicles other than mobile homes and recreational vehicles. Does this look familiar? It's basically the same thing as over there in NFPA 70E. Number 2, installations underground in mines and self-propelled mobile surface mining machinery and its attendant electrical trailing cable. We're not going to go through all these. We already read these in the other one. One thing that I do want to point out is that although these are not covered by the NEC, that does not mean that these installations are not covered by another type of regulatory code, right? The railroad, the utility companies, they all have different codes. So just because it's not covered in the NEC does not necessarily mean that it has no governing agency telling the installers how to install in those type of situations. I just really wanted to point that out because a lot of people think that the NEC covers everything, anything electrical, automobiles, all this stuff. It doesn't, but they have their own code that they have to follow through different governing agencies. A special permission. The authority having jurisdiction for enforcing this code may grant exception for the installation of conductors and equipment that are not under the exclusive control of the electric utilities and are used to connect the electric utility supply system to the service conductors of the premises served, provided such installations are outside a building or structure or terminate inside at a readily accessible location nearest the point of entrance of service conductors. So this section is telling us that the AHJ has the ability to allow an installation to not follow the code if they deem that it is a safe installation. They have a lot of power. That's a special permission that can only be granted by an authority having jurisdiction. It's typically not something that we come across. We usually just go by the code. The inspectors know the code. I've never seen a special permission myself. Perhaps some of you guys have, maybe the guys who've been here in the trade longer, maybe you guys have seen it, but I have not. 90.3, this is important. This is our code arrangement. This gives us a visual understanding of how this code is broken out. This code is divided into the introduction and 9 chapters, as shown in figure 90.3 below. Chapters 1, 2, 3, and 4 apply generally. Remember, we heard that term in NFPA 70E as well. 1, 2, 3, and 4 apply generally to all installations. Chapters 5, 6, and 7 apply to special occupancies, special equipment, or other special conditions and may supplement or modify the requirements in chapters 1 through 7. So let's look at a visual. Chapter 8 covers communications and is not subject to the requirements of chapter 1. That is the one chapter, like it says here, that is kind of its own lone wolf, if you will. It has its own requirements, and it has to do with communication systems, except where the requirements are specifically referenced in chapter 8. So some of the code sections might be referenced in chapter 8 that are in other sections, and then it does apply to communication systems. Chapter 9, tables that are applicable as referenced, and informative annexes are not part of the requirements of this code, but are included for informational purposes only. Remember, informational annexes and informational notes, which we'll see again down below, are therefore helping us to understand the code more. Here's the picture that we're looking at. Chapter 1, general. Chapter 2, wiring and protection. Chapter 3, wiring methods and materials. Chapter 4, equipment for general use. Chapter 5, special occupancies. Chapter 6, special equipment. Chapter 7, special conditions. And Chapter 8, communication systems. Chapter 9, tables. And then we have our informative annex A through informative annex J. Again, chapters 1 through 4 apply generally to all electrical installations. Chapters 5, 6, and 7 supplement or modify chapters 1 through 7. Chapter 8, communication systems. Chapter 9, tables. And your informative annex A through informative annex J. 90.4, enforcement. This code is intended to be suitable for mandatory application by governmental bodies that exercise legal jurisdiction over electrical installations, including signaling and communication systems, and for use by insurance inspectors. The AHJ, or authority having jurisdiction for enforcement of the code, has the responsibility for making interpretations of the rules, for deciding on the approval of equipment and materials, and for granting the special permission contemplated in a number of the rules. By special permission, the authority having jurisdiction may waive specific requirements in this code or permit alternative methods where it is assured that equivalent objectives can be achieved by establishing and maintaining effective safety. Again, the AHJ has the power to do that, but their goal, again, is to establish and maintain effective safety. This code may require new products, constructions, or materials that may not yet be available at the time the code is adopted. In such event, the authority having jurisdiction may permit the use of the products, constructions, or materials that comply with the most recent previous edition of this code, adopted by the jurisdiction. 90.5, mandatory rules, permissive rules, and explanatory material. A, mandatory rules. Mandatory rules of this code are those that identify actions that are specifically required or prohibited and are characterized by the use of the terms shall or shall not. We went over that in the last one. If they use those words, it's mandatory. Permissive rules. Permissive rules of this code are those that identify actions that are allowed but not required, are normally used to describe options or alternative methods, and are characterized by the use of the terms shall be permitted or shall not be required. C, explanatory. This is just talking about explanatory material, informational notes and annexes that are there for our informational information only. Informative annexes. Non-mandatory information relative to the use of the NSC is provided in informative annexes. Informative annexes are not part of the enforceable requirements of the NEC, but are included, again, for informational purposes only. And then we have, again, formal interpretations. You can go through that process. If you don't understand something, and you can send it in and ask for a specific interpretation directly from the committee so that you know exactly what that standard is saying. Again, we see here the pink. That lets us know that there was a change made from the 2017 to the 2019. Examination for equipment, for safety, wiring planning, number of circuits and enclosures, units of measurement, dual systems of unit. There's a lot of other stuff in here. Permitted uses of soft conversion, compliance, and that is the end of section 90 or article 90. Let's go into the next section. Introduction. We're not going to read, chapter 1, general. In here we see we have our definitions. We have article 110, requirements for electrical installations. And we have chapter 2 is wiring and protection. Chapter 3, wiring methods and materials. Chapter 4, equipment for general use. Chapter 5, special occupancies. Chapter 6, special equipment. Chapter 7, special conditions. 8, communication systems. 9, tables. Let's just look at one of these real quick. Article 100, definitions. We know what's in there. You guys need to find a definition about something. This is where you need to come. You need help interpreting one of the code references. You don't understand what something means. Come to the definitions, you find your answer. Article 110, requirements for electrical installations. This article covers general requirements for the examination and approval, installation and use, access to, and spaces about electrical conductors and equipment. Enclosures intended for personnel entry and tunnel installations. Approval. The conductors and equipment required or permitted by this code shall be acceptable only if approved. 110.3, examination, identification, installation, use, and listing. You haven't heard of listing. UL listing is anytime a product is created, it has to undergo testing by different testing laboratories. A lot of people think that UL is the only listing agency. There are many different listing agencies. UL just happens to be one that is very widely known and used a lot. Installation and use. Listing right here. Voltages. Throughout this code, the voltage considered shall be that at which the circuit operates. The voltage rating of electrical equipment shall not be less than the nominal voltage of a circuit to which it is connected. 110.5, conductors. Conductors used to carry current shall be of copper, aluminum, or copper-clad aluminum unless otherwise provided in this code. Where the conductor material is not specified, the sizes given in this code shall apply to copper conductors. Where other materials are used, the size shall be changed accordingly. Conductor sizes. Conductor sizes are expressed in American wire gauge, AWG. I like to say AUG. You can say it however you like, or in circular mills. You got your 12 gauge, 10 gauge, 8 gauge, all the way down, and then you got them going up. 22 gauge, we got our 0 to 10 wires that are typically somewhere between a 16 and a 22 gauge for our 0 to 10 volt dimming, things like that. AWG, or circular mills. 110.7, wiring integrity. 110.8, wiring methods. 110.9, interrupting rating. 110.10, circuit impedance, short circuit, current ratings, and other characteristics. The overcurrent protective devices, the total impedance, the equipment short circuit current ratings, and other characteristics of the circuit to be protected shall be selected and coordinated to permit the circuit protective devices used to clear a fault to do so without extensive damage to the electrical equipment of the circuit. This fault shall be assumed to be either between two or more of the circuit conductors or between any circuit conductor and the equipment grounding conductor permitted in 250-118. There's a whole lot more in this article. We could keep reading. One thing that I want to point out for those of you who might be working toward becoming a journeyman, becoming a master electrician, there are a lot of different resources for you to take your test. You can, I found, search online. I think there's electricianpracticetest.com. They have, I think there's 25 different tests on there. And all it is you go on and it's question after question after question after question. So if you're in that point in your career where you're looking to move and get that new license, look for that. That's a free resource. They do sell a lot of training courses where you can go on there and they'll help walk you through. And some of those are good. I like to try and find the free stuff myself. And I found that if you just answer question after question after question after question, use the table of contents, use your index, use all of those things in the code. And the more questions you answer, the better you're going to get and the faster you will get. And the more coverage you will get throughout the code book. So that's how I ended up passing my test. Just question after question after question after question. Look in the index, see how things are situated. Sometimes you'll find an answer in the table of contents, but you can't find it in the index. You look in the index and you can't find that answer in the table of contents. So you kind of have to jump all over the place, but just take a bunch of questions and answer them over and over and over and over again, so that you can take a step to that next level. All right, I want to move on from this and bring you guys to the lighting, my favorite aspect of the electrical industry. I like the instant gratification that comes. I know right away whether something works or not. It's the same with receptacles. You can put a plug tester in there, but the fact that the lights come on, I mean, we're working with some pretty intricate systems where we have fixtures that face down and up, direct, indirect light fixtures. We have power packs, we have motion sensors, daylight sensors, we have all of this different stuff. Wireless communication, wired communication, wireless communication, where you have these switches that you have to wire into line voltage, but then the communication is a wireless Bluetooth communication or a wireless radio frequency communication. It's very intricate. It has been very satisfying, and it really never lets down because the technology is constantly evolving, constantly changing. And for those of you who have had experience in the lighting world, installing these systems, it is I love it. I turn the lights on, I see lights out, I have to go troubleshoot, my brain's spinning. It's making me super mad, but then when I finally am able to figure it out, that satisfaction comes in. So perhaps you love single line. Perhaps you love um, rope and walls. Perhaps you love the whole hog. Perhaps, I don't know what your particular little niche is within the electrical industry that you like, but I mean, everybody has theirs. And for me, it's lighting. And so I think that you guys can gain some good information from me going over this stuff. So I want to take you guys right here. So this building is a 2-story, 20,000 square foot facility. It is in the pharmaceutical industry. They do science experiments. They work on mice. They're creating different medicines, vaccines, different things like that. They came to us asking if we would go into their building and we would completely retrofit the lighting. So we have an active facility. People are already there working. We had to create zones throughout the building, give them dates that we were going to be in those zones, and make sure that we hit that schedule that we created. So to start, you can see this is, let's go back up to, these are the approved building plans right here for a building here in California. This is a building Gilead. We are looking at breakdown here. This gives us our lighting layout. It is just a preliminary drawing. We had to do some edits on this, change the fixtures out, actually go in. The first step for us, for me, actually was to go walk this building. We had a set of as-builds that was provided to us, and from a previous contractor who did the initial installation. And we went in and I had to walk every single light fixture and verify that the light fixtures that were shown on the prints had not been changed over the years. Back in 2015 is when they did the transformation here. The remodel. They did a remodel in this building, and that happened in 2015. So we needed to go in and verify that they actually installed what they said that they were going to install. So I walked the building, put check marks on every single fixture. If a fixture had been removed, I removed it from the prints so that we didn't pay for an extra fixture that we did not need to be there. Then we got to the next step. Once we had our counts, I had to deal with our project manager and figure out what lighting control system they wanted. This particular building has about 8 different buildings, and they had a specific lighting control system in there, and they they wanted to match. So they wanted us to use the same lighting control system. So that's what we did. I then had to figure out, now that we had the lighting control system set, what type of lighting controls were we going to use, because this particular manufacturer has varying options. So you have the wired, and wired is what it's called, where you have to run Cat5 cables for communication all throughout a building, or they had the wireless communication. So we had to try and figure out what we were going to do, what was going to be the best application, the least invasive and the most cost efficient for us, while at the same time still providing them with the energy savings that they were looking for. That was the whole reason for doing this. They had fluorescent fixtures in there all throughout the building. They wanted to get rid of those fluorescent fixtures. We ended up providing them with about a 65% reduction in overall electrical cost. So their kilowatts per hour went down substantially. This building is now done. I'm in the preliminary stages, actually about to start the job come up next week. So I had to go through the same phases, learn some things from doing this first project, changed a couple things around. But let's go into the wiring diagram. I want you guys to see this. So you get into this system here, and this is a breakdown. So this is going to show us the components of this lighting control system. They're all different. They're all pretty good. Some of them are better than others. This one is pretty good. Some of them have more installation costs to it because you have more wires you have to deal with. So they just differ. It's really up to personal preference for the owners, what they want. And like I said, for this one, they went ahead and went with Enlight. So you can see here, the way this system is set up is it has what we call a main brain. It is a main brain for the entire system that houses all of the program, okay? So I want this light to turn on at this time. I program it in that, what they call an eclipse. It keeps the programming, just got a little computer in it. It knows what it's doing. You tell it what to do with a specific program, and it does it. The way that this system is set up is the communication in this picture is all Cat5 communication. So what I want you guys to think about when we're talking about Cat5 communication, okay, you need to differentiate in your mind the communication side from the power side, okay? You have the power side, which is our line voltage. That's what we call it. For those of you who don't know what that means, that is our power coming from the panel. Sometimes you have 120 volt lighting. Sometimes you have 277 volt lighting. In other countries, they use different voltages. But here in the United States, it's typically 120 or 277 for your lighting. The control system, and anytime that I am explaining Cat5 or communication, that is completely separate from the line voltage. You still have to have line voltage. We are not providing power to the fixtures to turn them on from the Cat5 low voltage. We cannot do that. The efficiency is not quite there yet. There are some PoE systems, which is called power over Ethernet, where they're actually now powering light fixtures from an Ethernet cable, a Cat5 cable. It's pretty crazy. Think real quick. What do you think some of the issues are with Cat5 and trying to provide power to the fixtures? Think about it for a second. Well, the number one thing is efficiency, right? So when we talk about power or amperage current going to a fixture, we know that we can only push so many amps over a wire that's this big. So you have Cat5 wires that are super small. I don't know what the gauge of them is, but they're very small. And you're trying to push, I mean, even though these LEDs are pretty efficient fixtures, they're still not that efficient to where we can push, you know, half an amp, a full amp, 2 amps through these Cat5 cables yet on a massive scale, right? So a lot of our lighting control, you see our circuits, we have tons of light fixtures on a 277 volt circuit. Well, we're just not there yet. Now, as the efficiency gets better, as we're able to provide the same amount of light with less amps, we'll start to see these new systems, these PoE, we'll see them start evolving as we reduce our energy consumption. But for now, what I want you guys to do in your brain is to differentiate. You got your power side and you have your low voltage communication side. I'm going to use terms that are going to kind of bring the two together for you. And also, we want to make sure that we're not forgetting that we are talking about the NEC here. So we want to talk about how strapping of MC, supporting of boxes, different applications. You guys be thinking about that as we're going through. I really want you guys to learn from this. So think about these things. You know, hey, look here. This is an as-built. So I want let's start here real quick. So you got your main brain right here. Then you have what's called a bridge. Okay, this bridge is, think of it as a branch panel. Just think of it as an electrical panel. But remember, differentiate communication from your power side. Okay, this is like a branch panel. Each one of these ports that you see right here coming out, that's like a switch leg that's coming out. So you're bringing a switch leg out of that bridge to a specific group of lights. So let's take, for instance, one little office. Let's find an easy one. Maybe this one. Let's go to a different sheet here. Be easier for you guys to see here. No. Right here. So in this room, this is what we would consider one control zone. So this is one office. Here's the door. Everything's kind of hiding it right now, but here's the door. They walk in, they have two fixtures. There's maybe a desk back here on the back wall, and they come and they sit in their chair. And these are the two fixtures and one switch on the wall right here, and a motion sensor and a power pack. This square box is a power pack, or it's a relay. It's basically a switch. And then you have your, what we call low voltage switch. This is one control zone. So I'm going to bring a home run from my bridge, and I'm going to land that in this power pack. And then I'm going to jump from this power pack to this motion sensor. And then from this motion sensor, I'm going to go to my switch. And then I'm going to stop, because that is my switch leg. And by taking my Cat5, I've already brought, remember, power communication. I've already brought my line voltage here. I've brought my line voltage into my power pack. I've broken it, just like a switch. It's a relay. And I tied the hot side into the line side of the relay, and I tied the switch leg to the load side of the relay, and it went out to my light fixtures. That's this right here, this wire, and then it jumps over here. So this is now my actual switch. But how do I tell it what to do? How does it know when to turn the lights on? Well, that's where the Cat5 comes in. I run from my bridge and I land into my power pack. And then I come out of my power pack and I land in my motion. And then I come out of my motion and I go into my power, or my switch, my low voltage switch. So what happens here is, when I do the programming for this office, I am going to tell this power pack to listen to this motion sensor and to listen to this low voltage switch. So guess what happens? When I come in the room, if this motion sensor is turned on, if I have programmed it and it's all set up, I'm going to walk in this room. This motion sensor is going to detect my motion. And it is then going to tell this power pack to close the relay and allow the power, again, power side communication. We're talking about the power from the 277 volt panel now. Allow that power to flow through this power pack, out this wire, into this fixture, and then into this fixture. Lights come on. Now, what happens if I come over here to the wall and I press the switch to turn it off? Well, I'm overriding the motion sensor now, and I am now telling the power pack that it needs to open. Relay open, no voltage going through. Relay closed. Think of your fingers like this. If it's open, there's no power going through it. If your fingers are closed, power can flow through there. That's what's going on here. In simplest terms, that's how this entire system works. It can get really intricate. You can start setting up points lists where they can have a building management system and they can view every one of the rooms. They can see if somebody's in that room or not. This particular building, they actually did that. They wanted us to set that whole system up so that in one of their buildings, they can monitor and they can see when someone's in their room and when someone's not in the room. And this isn't surveillance. there's no cameras that are watching in these specific rooms. What it's doing is giving them the ability to see the rooms that have a higher usage and to see if there's some way that they can reduce the amount of energy in that space. So let's say you had a room where there's a whole lot of people all the time, a break room, a bathroom, something like that, and there's high foot traffic in those areas. They might want to reduce the lumen output in those rooms, because they know that they're going to be on for a longer period of time. Plus, it's a break room. You don't need the lights to be at 100%. So they'll dim them down in the programming so that when someone comes into the room, instead of the light fixture coming on, let's say at 100%, it only comes on at 70. And really, to the naked eye, 100 to 70 is pretty substantial. You'll be able to see it. But if you go from 70 to 60, a 10% drop, you're not really going to see it visually. So that's something to keep in mind as far as energy savings for those of you who are installing lighting control systems, whatever the product may be. You can, and also for you employers out there, you can sell energy efficiency. It's big. People want to save money. They don't want to spend tons of money on their electricity. And so if you can bring them a service that hey, I'm going to save you an overall savings of 40% on your lighting load, which tends to be the biggest load in buildings, depending on what type of occupancy it is. If you can provide that service to them, that's fantastic. And people love that, especially the bigger buildings. They're really looking for this right now. And if you can provide that, and then also if you understand these systems, you apprentices and journeymen, and I mean even foremen and master and wherever you are, you need to understand this, because these systems are only coming more into the market more and more, and you'll give yourself a leg up in the industry by far if you can understand these systems. And a lot of these different manufacturers, they have free training programs that you can go on. So if you are installing one of these systems, I know Enlight is in the Dallas area. I think they're in Austin as well. I don't know if you guys are in that area working on those buildings, but they have all of this stuff going on, and it's really good to learn these systems. And then also keep in mind, when we're roping the MC, we have to make sure that we're strapping it right, that we're putting the bat wings on, that we're installing the J boxes appropriately, that we're using ground tails in our boxes per the NEC, that we're making sure that we're tying off our light fixtures and we're screwing them off if that's required. Every single one of our lighting installations needs to be like that. I want to spend a little bit more time in the code book here, looking at some other things, and then I want to move on from lighting and I want to get into power. I know we were using the term power before as it pertained to lighting, but I want to look at power from our receptacle side and our distribution side of that power for equipment and just general use, whatever it might be in a kitchenette. With you got your coffee makers, you got your blenders, you got whatever it is, your dedicated circuits, your non-dedicated circuits, your general use receptacles, how they work. We'll talk about that a little bit. We'll talk about, I just want to focus in. We did some lighting. I want to hone in on some power. So let's keep going on the code here for a little bit. We looked at Article 90, the introduction to the code book. We looked at origins, the committees, how they're made up, how changes are made, how you can input a formal interpretation to ask a question to these committees. We looked at Chapter 1. We looked at the definitions in here. We looked at 110, requirements for electrical installation. Let's go into Chapter 2 a little bit. So in Chapter 2, we'll see the use and identification of grounded conductors. We'll see branch circuits. We'll see feeders. We'll see branch circuit feeder and service load calculations. That's a great one to help us figure out sizing, right? Figuring out the calculations for a specific installation. I'll give you an example of that. I just went through what's called the EVITP program. Something you'll learn about me if you guys continue to use me is I love certifications. I've got a lot of different ones. I always have to do continuing education, just like you guys. And I always like to pick some sort of course that is going to give me something out of it. I need to learn something from it. So hopefully this course has been somewhat informative to you guys. I would encourage you to take different classes, whether it's for continuing education or not. Go get more certifications. The EVITP, that stands for Electric Vehicle Infrastructure Training Program, EVITP. I actually just got my certification in the mail when I came home today. As far as load calculations are concerned, branch, circuit, feeder, and service. So let's take, for instance, you have a client who wants to install some electric chargers on their site, right? Whether you're doing commercial or maybe it's just a residential. How do you know what size wire you need? How do you know what size breaker? How do you know all of that stuff? How do you run those calculations? Well, we can find answers, number one, on Google. Number two, right here in the code book. And really, it's a compilation of both. You know, I don't know everything. You don't know everything. We're never going to know everything. We're going to forget things that we used to know. You guys going through an apprenticeship program, you're learning a lot of stuff that you think is absolutely worthless at times. I'm here to tell you that it is not. I'm finding that as I move forward in my career, the things that I learned in the apprenticeship actually apply now. So whatever it may be, whatever class you're taking, don't ever think that is just absolutely worthless information. Who knows? You might end up being a PM. You might need to know load calculations. You might need to know AC DC theory. You might need to know all of these things that you're going through right now. I know it doesn't look like that. Hey man, I just want to put switches in. I just want to put receptacles in. You never know. So it's important. Pay attention and go after more certifications. That makes you more valuable to companies. The more it's not the piece of paper, it's the knowledge behind that piece of paper, right? So when we went through this EVITP program, we learned all about the code calculations. Did I remember them all from my apprenticeship? Absolutely not. But did I at least remember being exposed to that in the apprenticeship? Continuous loads, non-continuous loads, figuring out, I mean, what do you do when you walk into a building? This is something that I was thinking about as I was going through. What do I do when I walk into a building that has a 1970s or 80s electrical system in it, and I have to figure out how to add electric vehicle chargers to that system? Well, service load calculations, branch, circuit, and feeder calculations. You're going to use all of as we read through these different codes, you're not going to remember every single thing that we're talking about. You're not even going to remember 10% of what we're talking about. But at least you have that exposure, and then you can use problem-solving skills using the resources at your disposal, whether it's Google, whatever search engine you use, and the code book and people around you to be able to build systems. I had a foreman tell me once, he said, anytime his foreman asked him if he knew how to do something, he would always say yes. And then he would go figure out on his own or by asking others of his peers, whether they were apprentices or he was a journeyman, he'd go ask journeyman, whoever it was, ask them. I don't necessarily condone lying to your employer or to your boss. That might not be a track record that you want to have or a path, but you guys understand what I'm trying to say. Use the resources that you have. And in today's technological age, we have so many resources. I'm an electrical foreman. I run big crews. I run big buildings. I run, you know, does that mean that I never look at my phone? No, that means that I look at my phone way more than I used to, because roping MC to me is like, it's very simple. Does that mean I'm better than you? No, I just have the experience. All I'm trying to say is every step of the way, you're going to continue learning, and you're going to continue to need to use the resources at your disposal to help you get there. Like I said, don't lie to your foreman. Maybe have the response. I'm not exactly sure. I learned some of that in the apprenticeship. If you give me a little bit of time, or you want to spend a little bit of time with me, help me understand this more. Help me understand exactly how you want it installed. And that's another thing. I go off on rabbit trails a lot. I'm okay with it. I hope you guys are. If you're told to do something, just do it. The responsibility outside of safety relies on the foreman and your superior. If he's completely botching something up, I mean, you might try and find a respectful way to talk to him. You know, put it in the form of a question. Do you think that we could maybe try it this way? You know, or I did some research last night and I was thinking that this might be a little bit of a faster way to do it. That's one thing I learned in my career, is turn things kind of into a question, to where it's very respectful to go to your superior that way and ask him a question, rather than going and telling him that he's wrong and he needs to change it. We all know how we react when someone comes to us like that. Get out of here, get off my job. Boom, done. Hopefully you haven't been through that. I've been through it once. I spoke up, I got really mad at somebody, and I was gone. Lesson learned, right? But be respectful. Talk to people with respect. Turn things into a question. And hey, what do you think about this? Do you think this might be a good? Because then that turns it on them, that they feel that they are the one who is making the decision. And ultimately they are. But do you understand what I'm saying? How that kind of turns that around and helps them to lead, because that's their job. Their job is to lead. And again, you come to me as an apprentice like that, you're showing me that motivation, you're showing me that dedication, and you're being respectful, even if you disagree. That respect is going to be reciprocated, and I'm going to give you more opportunities. I'm going to give you more chances, and I'm going to pour into you the knowledge that I have gained over the years. So all of that from Article 220. We're never going to get through this code book, but that's fine. Article 225, outside branch circuits and feeders. Article 230, services. Article 240, overcurrent protection. Article 242, over voltage protection. Article 250, grounding and bonding. Again, Chapter 2, wiring and protection. This is where you go. Most of the time, if I have a question, I will look it up online first, because I don't know specifically where it's at in the code. I'll look at different forums. There's a lot of different places where you can find the information. Just type in your question, find it, but then make sure that you go back and reference the code itself. Because just because you found it on some website that looks legit does not mean that it is. So make sure that you do your due diligence and go back. Over the years, I have found some really good resources that have helped me in my career. ecmag.com, electrical contractor magazine. I used to have it shipped to my house every month. They would send me a free magazine. I don't know if they're still doing it or not. I moved, so I didn't move it with me. But it's a great resource. There's so much information out there. YouTube these things, but make sure, like I said, that you're back checking, because ultimately the responsibility is going to fall back on you, especially you foremen and you building owners and you master electricians, not building owners, business owners. You guys have a massive responsibility, and do not forget that. Do not forget that about your responsibility to keep people safe. And I keep saying that because I want it to ring in your ears the next time you're out on a job site, or the next time you're in someone's house and you're thinking about cutting the corners so that you can save, $100. It's not worth it. It is not worth it. Do it right. Be professional. I can't tell you how many people have told me how happy they are with my work, and I get calls back. That is not me being prideful. That is not me puffing myself up. That is me just living by certain principles. Like, I'm going to do this right. I'm going to do it right the first time. And if I make a mistake, I'm going to own up to it, and I am going to make it right. That's all that it takes. It is nothing special, Be that type of a person and you will succeed. If you are not that type of a person, you're going to struggle. I mean, I heard it one time. Somebody told me there's two things that you need to know. It was he was a pastor, and he was preaching to a seminary graduating class. And he went up there and he talked to them, and he said, there's two things that I want to leave you guys with. And it was the last thing. And the guy was telling the story. He said, everybody like scooted up in their chair, because he's a very reputable pastor. He leans up in his chair. All the people, they get their pens out and they're ready to write. And he said two things: show up early and do what you're told. That's it. That's all we have to do. If we do that as we progress in our career, whoever your superior is, whatever the level is, if you are a business owner, your superior, as you know, is the client. You need to make them happy. If you are an apprentice, it's a journeyman, foreman, general foreman, and all the way up the ladder. If we can all just do that as a group of electricians, we're going to make such a better name for ourselves and better names for us as individuals. And you will succeed that way. Show up early, or just period, show up. That's hard enough for some people to do, from what I've heard from homeowners or whoever I'm doing work for. These are the types of things that we need to have in our minds when we're going out there and we're installing. Like, it's a big deal. I'm considering right now going off on my own. I have been considering it for a long time. I'm working for a contractor, thinking about it, and it keeps in the back of my mind constantly, Stephen, you understand what responsibility you're going to have when you go off on your own. I mean, you are now going to be liable for every single mistake, every single anything. I mean, we think about, we get a license, we get a bond, we get these things to protect us. And then at times we can become lackadaisical. We can become complacent in our work. And yeah, I'm not here to beat anybody up. I'm just trying to share with you what I've learned. And let's not get there. If you've been in that place, you've gotten somewhat complacent, just start from where you're at and move forward. That's it. Pick it back up, pull yourself up, do whatever you got to do, and just get back into it right now. That's where you start, and you get back on track, and you're going to excel. You're going to be able to provide for your family. You're going to be able to enjoy life. I mean, we make really good money, and it's a really good trade to be in. So sorry about that, but that's just how I am. So where were we? Wiring and protection. Next section. Chapter 3, wiring methods and materials. Article 300. Article 300, general requirements for wiring methods and materials. Article 310, conductors for general wiring. Article 311, medium voltage conductors and cable. Article 312, cabinets, cutout boxes, and meter socket enclosures. 314, outlet, device, pull, and junction boxes. Conduit bodies, fittings, and handhole enclosures. 320, armored cable type AC. 322, flat cable assemblies type FC. This is where you're going to find all the information you need regarding your wiring methods and your materials. You have a question about supporting MC. Look here, right here, section 330. You want to know strapping, you want to know all that stuff, that's where you're going to go. Type MC cable shall be listed, right? It's got to be listed by some listing agency, whether it's UL. We really don't have to worry about this. If you're getting it from any type of reputable company, that whether it's CED, Home Depot, Lowe's, Rexel, Walters, it doesn't matter who it is. you're getting that material from somebody, it's probably going to be UL listed. We ran into a situation where it was that facility I was telling you about where the LI switch dropped off the forklift. In that the electrical safety video, we went over that. They had to special order this transformer. I have never seen a transformer this big. It literally was 10 by 10 by 10 feet, 10 feet by 10 feet by 10 feet. The facility, as much as I can say or tell you, is it was a Department of Defense building, and they were creating some sort of high capacity laser. I don't know if it was one that goes on an aircraft or if it was one that goes on some sort of ship, or I don't know what it was. We had to have a chaperone everywhere we went in that facility. He had to stand next to us the entire time. Maybe not, he was in the vicinity where he could see us, and he was watching us the whole time or sitting on his phone. But it was a massive transformer, and we hooked the whole thing up. We had, I wish I had pulled up a picture for you guys. Feeders like you've never seen before, just all over the place. It was parallel feeds, huge, absolutely massive. And we got to the very end. Inspector came out and he said, "Where's the UL listing?" And we were like, "What? Of course it's listed. It's a huge transformer. How did they get away?" And we started looking around. We looked at the nameplate. We looked all over the transformer. It was not listed. It was, we didn't even know what to do. We had never ran into a situation like that. My foreman was like, "I don't even know what to do." He called the office. The office, long story short, what ended up having to happen is they had to get a UL listing agent to come out and check the entire transformer to make sure that it was in compliance. And he actually found some mistakes. This particular transformer came from a different country, got shipped out, and it was missing a bunch of bonding jumpers. And they had to use this specific, it was like welding cable. I don't know if you guys ever ran across welding cable, but that it was these special order welding cable grounding bonding jumpers that we had to install in multiple locations. We ended up getting the listing, but that's just a prime example. You never know. You never know what the listing is, or if it even has a listing. And then you need to pay attention to what it's listed for. Certain MC cables have UL listings, or MC connectors have UL listings that others don't. Some can be used for 277, some can't be. Some can be used in concentric boxes, the ones where you pop out the knockouts out of the sides. You guys have seen them. Some can be used in those if you're using certain voltages, and some you can't. So you need to be mindful of these things. Spend a couple extra minutes. Look at what you're installing. Learn. Every day you need to walk away having learned at least one thing. We've all heard that saying, right? But focus on that. Check things out. I mean, I've gotten called on a couple. I had that exact thing happen, right? We had these 411 boxes with the concentric knockouts in them. And one of my lead journeymen told me, "I'm not using those. I'm not using those concentric boxes." And I said, "Why not?" He said, "Because I can't stab an MC connector in there." And I was like, "What are you talking about? Like, we've been using these for years." And he said, "It's not listed for 277. If it was 120, we could use it." I said, "Dude, you are so full of it." And he said, "No, they are not listed." He said, "You show me where it says that they're listed and I will use them." And I was like, "All right, challenge on. Let's do this." So I spent about an hour running through all of the checks to make sure that that MC connector was able to be used in a box with concentric knockouts at a voltage of 277 volts. And I brought it all to him, laid it out, and he was fine with it after that. He's like, "Wow, I didn't know that." It actually was on the side of the MC, the box that they come in, that it says on there, listed as a means of cable support, was what it said. And it had something else, and I don't remember exactly, as far as the 277 volt voltages in there. And I mean, a lot of times those guys are a pain in the butt, but I mean, I learned something that day, and I walked away having really, he learned something and I learned something. So that's all I'm saying. Just pay attention on the job site. Look at the things you're doing. Ask questions, and don't be afraid to ask questions. Don't be one of those guys who thinks that you know everything and then you end up making mistakes. That's way worse. That's going to make somebody way more mad than it is if you ask them too many questions, But something I do, I like to ask different people. So don't always go to the same person for the question that you ask. Go to multiple people. And that way you're not kind of bombarding one person with a million questions. And if you do have a lot of questions, one thing my general foreman taught me, he said, write me out a list and tell me that you want to meet with me every Wednesday or twice a week, if that's what it need be. Write a list out and come to me with a whole bunch of lists instead of calling me 15 times a day. The second in command of our company, I had to fly up to their location, and he kept getting a phone call all throughout the day while we're trying to work, we're trying to do this. He kept getting a phone call, and it was the same person. And he told me at the end of the day, he's like, I just can't stand this guy. And I was like, what is it? What is it about? He's like, he calls me with these one question calls. And he told me, don't do that. Give me a list. Spend the whole, I don't care if you call me once a day, but have all of your questions there that day or at that time and ask me all of them. And then have the self-control to wait till the next day if you have more questions. So I don't know, just trying to share some simple things with you guys because it's what's helped me in my career. So 330.10 uses permitted. You go into the MC section and it's going to break down all of the areas that you're allowed to use. This type MC cable shall be permitted as follows: for service, feeders, and branch circuits, for power, lighting, control, and signal circuits, indoors and outdoors, exposed or concealed, to be direct buried where identified for such use. Again, this is going back to the UL listing of it. Can you run MC underground? Yes. Can you run all MC underground? No. So it's got to be listed for that use. So you need to figure out and learn, hey, I'm doing overhead lighting. What MC do I use? I need direct burial MC, or I'm doing direct burial circuits. What MC? What's the cheapest and most cost-effective way that I can provide the service to the client and yet save us money, right? This all comes with knowledge and an understanding of the different materials. Go through the code book, break it out, look at the different types of materials. Again, watch videos on your free time. Instead of binging Netflix, spend 20 minutes watching. I don't do this. I'm not perfect at it. But when I have a question, I like to take the time because I have to. And I know that I am going to be more valuable to the company with the more knowledge that I have. And so that's what I focus on. And that's why I said I try to get more certificates. It's not for the certificate's sake, so I can look good on paper, because ultimately you'll be found out. You go through all these certification classes and you walk on with this massive resume, but you don't have the knowledge to back it. There's going to be a problem there, and they're going to find out. But again, the biggest thing that I've found is not that you know everything, but that you know how to figure it out. And once you get to a certain point in the trade, you will have enough knowledge, not that you know everything, but you'll have enough knowledge to be able to figure out pretty much any type of installation that you need to do. I recently started about a year ago as a service foreman. I've ran big jobs, and then I moved on to the service department, where I'm doing service jobs. And, you know, in the beginning of my career, I thought that, oh, that'd be so cool. I get a van to drive around, and it's cool. Don't get me wrong. I really like it. I enjoy it, but it's tough sometimes because you have to have a lot of knowledge. And you guys who are running in vans and service trucks, you guys know you have a lot of knowledge because you get exposed to client that calls for this, and then a client that calls for this, and a client that calls for this. And you have to be able to figure out these things. So again, it's not about having all the knowledge in the world. It's just having enough knowledge and enough drive and determination to say, I'm going to figure this out. So let's move on from the NEC. I want to go into what I was saying. I want to pull up another job that we did about 6 months ago. This is building for Dexcom. And what we have here, I want to pull up, this is the lighting print. So maybe we'll just, no, we're going to do power. I said we're going to do power. Let's do power. I always go back to lighting because it's my thing. All right, so let's just go over some of these symbols. Let's look at this drawing, and got to go up here first. If you don't know what the symbols are, every single set of drawings has symbols and legends, or symbols and descriptions. So we see here, this symbol right here, for those of you who don't know, this is a duplex receptacle. This is your normal receptacle that you see in your house. It could be the round one, or it could be a Decora. The Decora is the rectangle one. It all depends on what they've spec'd out for the job, or if you're in someone's house, what they want. Most people nowadays, they like the Decora look. They like to change out their switches, put some fancy dimmers in there with, you know, lights that light up. Or perhaps it's the type of person who just really wants a toggle switch because it's cost effective, it's cheap, and it works. So this is a duplex. This is a half hop right here. You see this shaded section on the one side? That's letting us know that half of the switch is hot and half is not. So what that means is, think about your garbage disposal, okay? Garbage disposal in your kitchen. You have a switch above to turn that garbage disposal on. Well, that receptacle, half of it is constant, what we call constant, meaning there's always power there. There's never a time when there's no power there unless the breaker trips or something like that. But the other half of that receptacle, the other plug, is connected to that switch. And it breaks the power, it breaks the voltage. If you want to know more, go on YouTube. I don't have the resources right now to pull it all up, nor do I want to do that with you guys. Go watch a video, look up half hot receptacle, learn about what that means if you don't know what it is. It basically just breaks the power. So you turn the switch off, there's no power at just that receptacle. Turn it on, there's power there now. It turns your garbage disposal on because you have your garbage disposal plugged into that receptacle. Does that make sense? On this particular drawing, the receptacle symbol with a D means dedicated. That's a dedicated 20 amp rated duplex receptacle. Dedicated means it is the only receptacle that is on that circuit. So you went all the way from the panel, all the way to that receptacle, and nothing else is daisy chained off of it. It is a dedicated circuit. You see this a lot. I mean, you see it everywhere. Sometimes you have a microwave. Most of the microwaves are dedicated circuits. In fact, I believe that the code states that it has to be a dedicated circuit. Or don't mark. I don't think that that's true. We'll look that up. Really, I think in bathrooms we should have an extra dedicated receptacle for a hairdryer. They pull like 9 amps, something like that. So I see it a lot where people are tripping that GFI that they have installed in a receptacle. You know, if you made that dedicated specifically to a hairdryer, you know, maybe in custom homes or something they do that, but that's not typically how we do it. GFCI, GFI right here, ground fault interrupter. This is what we see outdoors. if there's an issue, an imbalance in the electrical load, it is going to trip the GFI. 50% of the service calls that I get are because there's a tripped GFI somewhere. I always try to ask the person, what happened? What happened before this, before your power went out? They might tell me, well, I was using my hairdryer. Were you using anything else in your bathroom? Yes, I was using, my wife was using her her hair straightener, whatever, her curling iron or whatever. And or she has a plug strip plugged in there and she's got 15 things going at the same time. Well, that might be your problem. Unplug it, push in the GFI, and then unplug everything from the plug strip. First of all, throw that plug strip in the trash. Don't use that thing. That you have 2 plugs for a reason. Plug one thing in at a time, or maybe 2. So GFI. The point here is if you don't understand what something is, you need to look at the symbols and descriptions. You need to pay attention to this because receptacles are, this one, look at the H, horizontally mounted duplex receptacle, right? You need to look at those things. I mean, that's huge. You guys who, both residential and commercial, if we get that wrong and it's horizontal instead of vertical or vertical instead of horizontal, what's going to happen? It's there's tape and mud and there's paint on the wall. Guess what you're doing? You're ripping that thing open, and you got to turn the mud ring to the side and you got to put it back in. I mean, these simple things that we have to pay attention to. And I don't, just because you're not a foreman does not mean that you don't need to pay attention to this. You need to start now. Start now as a first year. Start now as a second year. Learning symbols, asking these questions. Again, it just goes back to asking questions. That is going to be your entire career. If you don't want to ask questions, again, you're going to struggle. So symbols list. Let's go back to our power drawing. So here we see some of those symbols, right? Here's a receptacle right here. Here's a receptacle, 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 right? What's this? The triangle, a data port. Okay, they want Cat 5 there. This is a huddle room. It's like a conference room kind of. They come in here. They want to be able to plug in their computers, whatever, get on the network, connect to the TV screen above. There's AV in this room, but that's on a different drawing. So typically on a power drawing, if there is no plus and then a dimension, you put it at whatever they have specified in the drawings, your height. We're talking about height here. So this right here, these 2 receptacles, this one and this one, are at typically plus 15, maybe plus 18, you know, whatever it is. But if you see a plus 60 or a plus 42 or a plus 46, whatever it is, plus 66, that's letting you know that they want center of that receptacle mounted at plus 60. Now, this room is a huddle room. You can see right here, it says monitor, monitor. There's a TV. You can see it on the wall. They're putting a TV on the wall. Just because it says plus 60 on the engineered set of drawings, the stamped set that comes from the city, just because it says that, that does not mean that that is the final height that it's going to go at. You need to look at AV drawings, especially when you have TVs going on the walls. You need to look at the furniture drawings. You need, because everybody makes mistakes. Engineers make mistakes. We make mistakes. You want to verify these heights, whether that's writing an RFI, a request for information. That's what an RFI is. This is typically done, maybe a lead journeyman, a foreman typically does this, where you will send in a request to the architect or to the engineer, whoever it is, and you will say, I need you to verify that this is actually the height that you want it to be at. If there is no height, then you go by what is spec'd out. So again, spec'd out means specification that has been provided by the architect or engineer. Really, it's the building owner. They have said what they want. So you come up here, and a lot of times it'll be in the drawings, right? Right here, normal duplex, no symbols, duplex receptacle mounted at 15 inches AFF. What does AFF stand for? Above finished floor. So that means above the finished floor, you're at 15 inches on center. Typically, they could want something else. They could want top duplex receptacle. Who knows? You need to verify these things. Ask these questions. Don't just think that, because I think the younger guys in the trade are the ones who typically falter on this. You need to know that this is not the Bible, so to speak. This is not gold. This is something that could have had mistakes in it. And oftentimes there are mistakes. We found tons of mistakes, discrepancies between the power drawings and the AV drawings. So you need to make sure that you are looking at all the different drawings that you have. And if there's any discrepancies, you need to ask the question. Raise your hand. Hey, there's something going on here. This doesn't match. It also goes for wire sizes. I was running a casino, and the engineer had designed these receptacle circuits. The casino, I was in charge of the site. So that is the pools, the pool building, all of the receptacles that are in the planners, all the lights, the site lighting, the pole lights, all that stuff. Well, some of these receptacles, I wish I had the drawing. I don't have it anymore, but some of these receptacles were 800 feet from the panel. What does that mean? 800 feet? Can you just run a number 12 gauge wire 800 feet and get your full 16 amps of continuous load at that receptacle? Of course you can. You have to look at these things. So the engineers make mistakes. I had to literally, on this site, I wish I could show you the drawing, literally go through every single circuit, run a footage on Bluebeam. This program right here, this is Bluebeam. So I'm able to actually take, I'll show you real quick, actually able to take measurements. I can't get to it. Oh, it's right here. Measure length. I can come in here and I can measure the distance. Obviously that door, what are doors usually? Are they at 1'5"? No, they're typically 36 inches. So my calibration on this is wrong right now. So I have to go in here. This is another thing. Learn Bluebeam. Learn whatever program your company is providing. For you guys who are not with the company who's doing work like this, learn whatever computer programs they have. Become more of an asset to that company. I just had a conversation with my company, and I told them, I said, how can I, so many people go up to their employer and they say, I want a raise. And their employer looks at him and says, okay, why do you deserve a raise? Well, because I work hard. Okay, I'm glad that you work hard, but this is what you are worth at your level. A first-year apprentice, you are not worth $75 an hour. A second-year apprentice, you are not worth $80 an hour. You're not worth that money because you don't have the knowledge yet. So when we go to our superiors, something that I learned that has been really beneficial is go to them and say, I want to learn what I need to know to make it to the next step. Can you help me get there? You see the difference in that from coming to him and saying, or him or her, sorry, coming to them and saying, I deserve a raise or I want a raise. Go to them, ask them the question, how can I get to the next level? How can I become more of an asset to your company? That is how you are going to progress in this, because then that puts it on their plate. And most people want to help other people. They want to teach. I mean, I'm sitting here talking to you guys, and I want to share this information with you. But so many people just don't take the steps to come and say, hey, man, they're not humble enough to just say, I don't know this. Can you teach me? Have that attitude. Go to your foreman and say, hey, give me a progress report. Where are my strengths? And more importantly, where are my weaknesses so that I can get better, right? That's where you want to be as an electrician. And that's how you're going to continue to grow and how you're going to get other people to pour into you so that by the time you're 50 years old, 60 years old, 70, you can then turn around and number one, teach other people, but be sitting in a position where you're like, man, that was a good life. I had a great career. I had a great family. I just continued to progress. I'm thankful for what God's given me, and I'm thankful for this life. You know, that's where you want to end up at the end. And so again, it goes back to be respectful. And I know you guys didn't come here for a pep talk, but this is what you're going to get. So, anyways, let's finish off with last little section here. Again, pay attention to your symbols, look at your heights, be detailed, be detail oriented. You know, look at every single, I literally go through every single room. Let's see if I have it on a different drawing here. No. I go through every single, there's a different drawing, maybe it's on my layers. No. And I look at every room, every device in that room. And it's not just the power print, right? We have telco prints, your data prints, you have your AV drawings, you have your single line drawings, you have your lighting drawings, you have fire alarm drawings. If you do fire alarm, you're into all of these different drawings that there's so much to learn, so much to continually be growing in, and just be that detailed type of person. And that's it. We got a couple minutes left. I'm super thankful to be able to be doing this for you guys. Please, if there's something I can change, something that I can do better to the course, you know, whether it's on the website that it's not easy to navigate, or, you know, hey, you want me to cover this in the next series of videos for your next continuing education, a question that you have, please do not hesitate to reach out. I'm really trying to build this business so that I can focus more on teaching. I really enjoy teaching. I want to build this business to bring in the income, so that at one point, maybe I do go off on just teaching and just running Sparky Education. If not, that's totally fine too. You know, I don't know what's in store for me in the future, but for now, if you have something I can do better, some way that I can bring more value to you as an electrician, please let me know. But again, this is fun. I really enjoyed it, and I hope you guys come back next year for more. All right, well, take care and God bless.